Before the first galaxies formed, before light itself could travel freely through space, the universe was already moving, not drifting, but spinning. Every atom, every planet, every galaxy dances to this silent rhythm, bound by invisible threads of motion. What if spin is not a byproduct of creation, but its very heartbeat? Like and subscribe, and together we'll unravel the greatest dance in the cosmos. Let's begin. Look anywhere in the universe, and you'll find rotation. Even in what we call stillness, there's motion so fast and subtle that space itself seems to hum. Everywhere we look, movement defines existence. The planets spin in their orbits, stars revolve around galactic centers, and galaxies themselves drift and twist through cosmic filaments like beads sliding along invisible strings. On Earth, we measure time by the turning of our planet, yet even the atoms that make up the clock are in perpetual spin. Stillness is an illusion, an artifact of limited perspective. When we zoom out far enough or peer close enough, everything we thought was quiet reveals a rhythm. This endless motion began in the very first seconds of time. When the newborn universe expanded from its hot, dense beginning, matter and energy didn't spread out perfectly evenly. There were tiny fluctuations, ripples in density, each becoming the seed of future motion. Gravity pulled on those ripples, drawing matter inward. As the clouds collapsed, they began to spin. Conservation of angular momentum demanded it. What began as the faintest whisper of imbalance grew into the roaring storms of galaxies and the whirl of planetary systems. Rotation is how the universe remembers its birth. Once something begins to spin, it cannot simply stop without sharing that motion elsewhere. Planets pass it to their moons, stars to their winds, galaxies to the dark matter that cradles them. Even the faintest speck of dust in a nebula holds a trace of ancient momentum, an echo of the universe's first turning. Every spin is part of that same inheritance. On the smaller scales, the motion becomes more mysterious. Inside atoms, electrons whirl around their nuclei, with speeds approaching the speed of light, not in neat orbits but in probability clouds, a constant shimmer of presence. Each electron has its own intrinsic spin, a kind of built-in twist of quantum identity. That spin gives matter magnetism, defines chemical bonds, and shapes the structure of the world we touch. The cosmic and the microscopic share the same choreography. And still, we seek rest. We imagine the vacuum of space as a still void, but even there, particles flicker into and out of existence, their spins creating quantum ripples that fill every cubic centimeter of space with silent energy. The cosmos hums, not metaphorically, but truly. A low-frequency vibration of existence itself. When we sleep, the Earth continues its slow rotation beneath us, turning us gently toward the morning. Above, the moon pirouettes in synchrony, pulled by invisible tides. Our sun too spins, carrying all of its planets along a vast, looping journey around the galaxy's heart. Even the galaxy spins within clusters that spiral through space-time. To exist in the universe is to move. Every turn, every breath, every heartbeat is part of this continuous rotation. Motion is not something the universe does, it is what the universe is. Somewhere, out in the deep dark, everything is still spinning. And so are we. Moments after the Big Bang, energy and matter were not evenly spread. Tiny ripples, imperfections, caused gravity to pull in uneven ways. Those small asymmetries gave birth to the universe's first spins, like eddies forming in a newborn ocean. In the beginning, there was only expansion. An explosion so vast that it created space itself. For a fraction of a second, the universe was perfectly smooth, a glowing fog of energy too dense for light to move freely. But perfection, even in the cosmos, is fragile. Microscopic fluctuations, quantum wrinkles frozen into reality, disturbed the calm. They were unimaginably small, yet they carried the blueprint for everything that would ever exist. As the universe cooled, gravity began to tug on those wrinkles, pulling denser regions inward. The Great Collapse began, not a violent crash, but a slow gathering of cosmic dust and hydrogen gas. With each contraction came rotation, conservation of angular momentum. The universe's quiet law of motion turned collapse into spin. It is the same reason a figure skater twirls faster as they draw their arms in. The universe, in its infancy, was performing the same motion on a scale beyond comprehension. Imagine it. Clouds of hydrogen, hundreds of light years across, slowly twisting into motion under their own gravity. At first, their movement was gentle, a subtle drift, barely measurable across eons. But as they tightened, as gravity deepened its hold, they spun faster and faster, flattening into disks, the first rotating structures in the cosmos. These were the seeds of galaxies, the foundations of stars, the architects of planets yet unborn. This was the first true choreography of time. Motion gave direction to what had once been chaos. The swirling of gas defined before and after, carving the arrow of time into the very fabric of space. Every rotation since has followed that primordial pattern, tracing the memory of that first twist. Scientists can still see the fingerprints of these early spins in the cosmic microwave background, the faint afterglow of the Big Bang. It carries patterns, anisotropies, delicate swirls of radiation that show where matter first began to clump and turn. Each of those tiny hot and cold spots represents a future galaxy, a future star, perhaps even a future world with oceans and skies. In a way, the first spins of the universe created the possibility of time itself. Without rotation, nothing could have coalesced. No planets, no stars, no you watching the sky. Spin gave structure to the void, dividing the infinite into cycles and seasons, giving rise to the rhythm of existence. Even now, billions of years later, the legacy of those first twirls endures. Every motion, every orbit, every turn of a planet, every spin of an atom is a faint echo of that moment when the cosmos first learned to move. The first twist of time never truly stopped. It only slowed. Enough for life to find its place within the great, eternal swirl. At first, the universe was chaos. Clouds of hydrogen gas collided and swirled under gravity's pull. Slowly, those random motions began to align, forming great spirals, proto-galaxies, spinning like cosmic hurricanes. In the young cosmos, order did not exist, only movement and collision. Enormous clouds of gas stretched across light years, drifting through expanding space. They merged, broke apart, and reformed in a restless ballet of creation and destruction. Each encounter left behind a trace of spin, a slow-turning momentum that began to spread through the cosmic sea. Gravity, ever patient, gathered these clouds together again and again, coaxing them into shape. Imagine it, billions of tons of gas, illuminated by the faint glow of newborn stars, spiraling through darkness. Gravity didn't just pull, it sculpted. The random chaos of matter found rhythm under its invisible hand. Small eddies grew into great vortices. Within these spirals, pressure built, temperatures rose, and deep within their centers, the first stars were born, tiny furnaces igniting against the cold of endless night. Each spin fed another. As clouds condensed into stars, and stars gathered into clusters, rotation became contagious. The universe learned the art of repetition. From randomness came symmetry, from turbulence came grace. The first galaxies emerged not as perfect disks, but as messy, luminous swirls, chaos learning how to dance. The process was far from peaceful. In those early epochs, galaxies collided constantly. Some merged into larger spirals, others shattered into fragments of stars and gas. Yet through every collision, a strange consistency endured. Spin never vanished. Angular momentum was redistributed, transferred, shared, but never lost. Even destruction contributed to motion, as though the universe refused to rest. The result was beauty born of disorder. Galaxies flattened into vast disks, their arms coiling like frozen whirlpools. Their centers blazed with newborn suns, while dark matter halos spun invisibly around them, anchoring their shapes. Within those rotating galaxies, smaller clouds began forming solar systems of their own, each inheriting the great cosmic spin in miniature. It's difficult to imagine the scale of this dance. One rotation of a galaxy can take hundreds of millions of years. From our perspective, they seem motionless, grand spirals painted across the sky. Yet if time were sped up, we would see them turn elegantly, their arms flexing like dancers mid-motion. The universe became a performance of gravity and light, every particle following steps choreographed by physical law. Over billions of years, this dance refined itself. Spiral galaxies settled into elegant order. Elliptical ones spun with subtle grace. Even the collisions that once seemed chaotic began to serve a higher structure, redistributing momentum in ways that preserved the balance of the cosmos. What began as chaos had found its rhythm. In that quiet transformation lies the heart of creation. The universe didn't begin perfect. It learned to move beautifully through trial and turbulence. What we see in the night sky, the spirals, the symmetry, the serene drift of galaxies, isn't the end of chaos. It's what chaos became when it learned to dance. Spin isn't just movement, it's a conserved property. Once something begins to rotate, it resists stopping. This law, called angular momentum, ensures that motion in the universe is never truly lost, only transformed. Angular momentum is the quiet guardian of motion, the principle that binds together every spinning object from the smallest atom to the largest galaxy cluster. It is one of the universe's simplest rules, and yet it is the reason stars are born, planets form, and galaxies keep their graceful spirals for billions of years. When something turns, it stores energy in its rotation, a kind of cosmic memory. You can see it in a child spinning on a playground, in an ice skater pulling their arms inward to twirl faster. What they are obeying is the same law that shaped the universe. As a collapsing cloud of gas shrinks under its own gravity, it must spin faster to conserve angular momentum. Every star, every world that emerges from such a cloud, carries the imprint of that ancient motion. Angular momentum is more than a law, it's a storyteller. It remembers the universe's beginnings. When planets were forming from dust and debris, their orbits and rotations were not random, they were inherited. The swirling direction of Earth's rotation, the tilt of Saturn's rings, even the chaotic spin of tiny asteroids all trace back to the same fundamental rule. Each one is a signature of the forces that once molded it. But this conservation also means that motion can be shared. When two bodies interact, say, a moon orbiting its planet or a star encircled by its worlds, angular momentum flows between them like a current. Earth gives a little of its spin to the moon, slowing our days while pushing the moon farther away. A star's winds carry its momentum into space, gradually changing its rotation. Even collisions, no matter how violent, never erase spin, they merely redistribute it. It's through this silent exchange that the universe maintains balance. Without angular momentum, the cosmos would collapse inward, motionless and formless. But because of it, systems stabilize, orbits persist, and chaos finds harmony. It is the invisible hand that keeps everything turning in perfect proportion. Scientists can calculate angular momentum precisely, yet its essence feels poetic. It's a reminder that the universe never wastes energy. It recycles motion endlessly, turning collapse into rotation and disorder into pattern. What was once linear becomes circular. What was falling becomes orbiting. What was random becomes rhythm. In a way, angular momentum is the universe's promise of continuity. When we spin a coin, toss a planet into orbit, or watch a galaxy whirl, we're seeing the same law at work, a thread of motion connecting past to present. Every spin, every orbit, every rotation is part of a cosmic pact. Movement endures. Long after stars fade and galaxies drift apart, their angular momentum will persist in some form. passed to the next generation of cosmic structures. Motion may change, slow, or fragment, but it will never die. The universe, by its very nature, refuses to stop turning. A star is born when a collapsing cloud of gas begins to spin faster and faster. Like an ice skater pulling in their arms, the cloud's rotation increases until fusion ignites at its core, light born from spin. In the dark womb of a molecular cloud, trillions of tiny particles drift together under the pull of gravity. These clouds are immense, vast regions of gas and dust stretching across light years, cold and silent but brimming with potential. Within them, small knots begin to form where density is just a little higher than the surrounding space. These knots pull in more and more material, their gravity feeding on itself, until they begin to collapse inward. But gravity's embrace is never smooth. It twists. And that twist becomes the seed of a star. As the cloud contracts, its rotation accelerates. Every atom, every molecule, contributes to a shared spin that grows faster, the tighter the collapse becomes. What was once a lazy drift becomes a roaring vortex. The gas flattens into a disk, swirling around a brightening center. Friction heats the material as particles collide, converting motion into energy. Slowly, temperature climbs. The dark begins to glow. At the heart of this whirlpool, pressure builds until hydrogen atoms are crushed together with enough force to fuse. That first spark of fusion releases energy outward in all directions, an explosion of light so intense it halts further collapse. The star stabilizes, its own radiation balancing gravity's inward pull. What began as a cloud of invisible gas now burns as a newborn sun. Every star you see in the night sky carries this legacy. Each is a spinning furnace, a self-sustaining engine powered by the balance between gravity and motion. Its outer layers churn like boiling water, while magnetic fields coil and twist beneath the surface, guiding streams of plasma in luminous arcs. Even in their apparent stillness, stars are in constant motion, rotating, vibrating, pulsing with the rhythm of creation. Around these stars, remnants of their birth disks linger. The leftover dust and gas, still spinning in orbit, begin to clump together, forming planets, moons, and asteroids. Every world that will one day circle that star inherits a fraction of its parent's rotation. The spin of a single cloud becomes the spin of an entire solar system, a lineage of motion passed down like a family trait. And when the star's time ends, it doesn't take its spin quietly. As it collapses again under its own weight, conservation of angular momentum accelerates its core to unimaginable speeds. Some stars become neutron stars, objects so dense they spin dozens of times per second, flashing like cosmic lighthouses. Others form black holes, where rotation drags even space and time into their whirl. From beginning to end, spin is the architect of starlight. It sculpts clouds into disks, ignites fusion in their hearts, and dictates their final, breathtaking demise. Each twinkling point in the night sky is not just shining, it's spinning, carrying the motion of creation within its glow. The next time you look up and see a star, remember that light began as a slow turn in the dark, a dance of gravity and time that set the heavens forever in motion. Around each newborn star forms a swirling disk of dust and gas, a cosmic pancake of motion. Within these spinning rings, tiny particles collide, stick, and grow. Planets are sculpted in the spin's embrace. In the shadow of a newborn sun, gravity and rotation perform one of the most delicate dances in the universe. The remnants of the collapsing gas cloud, the same material that once fed the star, flatten into a thin, glowing ring that stretches for billions of kilometers. This is a protoplanetary disk, the birthplace of worlds. Within it, dust motes and frozen grains drift in slow, hypnotic spirals. What seems like emptiness is, in truth, a storm of motion so vast that it shapes entire solar systems. At first, the disk is chaotic. Dust collides with dust, ice with rock, fragments shattering and reforming. Each collision carries a whisper of angular momentum, aligning particles into shared orbits around the star. Over thousands of years, the tiny grains begin to stick together, bonded by static charge, ice, and the faint glue of gravity. These particles grow into pebbles, then boulders, then mountain-sized planetesimals that carve paths through the swirling gas. The chaos begins to organize itself. As these planetesimals merge, their gravity strengthens, pulling in more material. Each collision releases heat and motion, shaping the new body's spin. Some form quickly, sweeping up debris in great arcs. Others linger as wandering rocks, never destined to become planets. The faster an object rotates, the more it resists collapse, balancing gravity's pull with centrifugal grace. Over millions of years, the disk begins to clear. The growing worlds claim their territories, sculpting gaps in the gas and dust as they orbit. The star's radiation pushes away the remaining debris, leaving behind a family of planets, each spinning, each carrying a fraction of the disk's original rotation. The solar system becomes a frozen memory of motion, its harmony written in the balance of gravity and speed. The evidence of this process still surrounds us. Astronomers have captured images of protoplanetary disks in distant star systems, rings glowing in infrared light, dark lanes cut by newborn planets. They reveal the same structures that once surrounded our own sun. Bright concentric bands of dust, gas, and possibility. Even across light years, we can witness the universe repeating its favorite pattern, spin transforming chaos into creation. Our own solar system bears the fingerprints of this ancient rotation. All the planets orbit in roughly the same plane, moving in the same direction. Their paths trace the outline of that original disk, their motions synchronized by the cosmic momentum that birthed them. Earth's day, the tilt of its axis, even the shape of its orbit, all inherited from that primordial swirl. The birth of a planetary disk is the moment when light and matter make an agreement. The star shines, the disk turns, and together they decide the shape of everything that follows. In this thin, spinning sheet of dust lies the blueprint for moons, oceans, mountains, and life itself. Every grain knows its role, every orbit remembers where it began. And when we gaze at the night sky, at worlds beyond our own, we are seeing variations of the same story, the eternal truth that from the spin of dust, creation finds its form. Once a planet forms, it inherits the angular momentum of its birth cloud. That initial spin becomes its day. Earth's 24-hour rotation is the fossil memory of its creation, preserved for 4.5 billion years. When a young planet first takes shape from the dust of its protoplanetary disk, it is already in motion. Every collision that formed it, every grain of dust, every rock, every fiery impact, added or adjusted its spin. In the beginning, these worlds turned chaotically. Some spun wildly fast, others turned backwards, their rotation reversed by titanic impacts. Yet through all the collisions, one principle remained constant. The universe never wastes motion. Each planet carried forward the spin of its birth, a physical echo of the swirling cloud that gave it form. For Earth, this ancient inheritance became rhythm. As it cooled from molten rock into solid crust, its rotation slowed but never ceased. The very act of cooling preserved its angular momentum, locking in a steady, graceful turn that would define the cycle of day and night. That rotation governs more than time. It drives the winds, the tides, the growth of forests, the migrations of animals. Every sunrise, every shadow, every heartbeat lives within that eternal turning. But why doesn't it stop? The answer lies in the perfection of balance. In the vacuum of space, there is almost nothing to steal momentum away. No friction, no atmosphere to slow it down, no surface against which to grind. A spinning world in space is like a top that never topples, free to turn for eons. The same principle that keeps a gyroscope stable holds the planets steady on their axes, maintaining the quiet, endless rotation we take for granted. Yet even this eternal spin is not entirely constant. Over immense timescales, The tides raised by the moon gently tug at Earth's rotation. The oceans rise and fall, creating drag that ever so slightly slows the planet's spin. Our days lengthen by fractions of a second every century, a small but inexorable change. The same gravitational tug pushes the moon farther away, conserving angular momentum across the Earth-Moon system. The balance is perfect. As Earth slows, the moon drifts, and the dance continues. Other planets tell similar stories. Jupiter, a gas giant so massive it could swallow 1,000 Earths, spins once every 10 hours, its immense bulk flattened at the poles by its furious rotation. Venus, on the other hand, turns the opposite way, its day longer than its year, perhaps the result of an ancient collision that flipped its spin. Every world remembers its past in the length of its days. Each rotation is an autobiography written in motion. When we watch a planet turn, from the delicate crescent of Venus to the banded storms of Jupiter, we're seeing time made physical. That slow spin defines the rhythm of existence. On Earth, it means dawn will always follow night. On Mars, it marks the gentle drift of red dust across its deserts. On distant exoplanets, it sculpts winds and oceans we may never see. In the end, a planet's spin is not just a leftover of creation, it's its heartbeat. It keeps worlds alive, skies moving, climates breathing, and though gravity may slow them and time may stretch their days, they will never truly stop turning. The universe, once set in motion, continues its dance without end, each planet spinning softly to the rhythm of the stars. Earth's axis is tilted, a leftover wobble from ancient collisions. That tilt, born from cosmic violence, gave rise to the rhythm of seasons, a reminder that even chaos can produce balance. Long ago, when the solar system was still young and wild, Earth did not yet know calm. It was a molten world, its surface a restless ocean of rock and fire, pummeled by debris left over from planetary formation. Then came one collision so immense that it changed everything. A protoplanet, roughly the size of Mars, struck the young Earth at a glancing angle. The impact nearly tore our planet apart. It melted crust, reshaped continents before continents existed, and flung molten debris into orbit, debris that would later gather to form the moon. But it also left behind a scar invisible yet profound: the tilt. Instead of spinning upright like a perfectly balanced top, Earth was set askew, its axis leaning about 23.5 degrees from the plane of its orbit. It was a cosmic accident, one born of destruction, but from it came harmony. That tilt became the reason for the seasons, the quiet engine that drives the turning of time across the world. As Earth travels around the Sun, that fixed tilt means that sometimes one hemisphere leans toward the light and sometimes away. When the northern half tilts sunward, it basks in long days, warm air, and summer's bloom. At the same time, the southern half turns away, sinking into the cool hush of winter. Half a year later, they trade places, an eternal exchange of warmth and rest, growth and renewal. Without that tilt, there would be no seasons, no shifting balance between light and shadow. The poles would remain locked in frigid stillness, the equator in endless heat. But because of a single ancient impact, life on Earth evolved within cycles, a rhythm that governs every forest, ocean, and living cell. Seeds sprout when days grow longer. Ice retreats when the sun climbs higher. Even human culture, our calendars, our celebrations, our myths, grew from this cosmic inclination. The tilt does not stay perfectly still. Like a slow-motion wobble, Earth's axis precesses over millennia, tracing a gentle circle in the sky. This slow drift changes the timing of seasons over tens of thousands of years, subtly reshaping climates and glacial ages. Even here, the universe refuses absolute stability. It prefers gentle motion, rhythmic variation, a slow dance between balance and change. Our moon plays a quiet but vital role in this stability. Its gravitational pull steadies Earth's tilt, preventing it from swinging too wildly. Without the moon's calming influence, the planet's axis might fluctuate chaotically, bringing unpredictable climates and unstable conditions for life. Once again, an ancient act of violence, two worlds colliding, produced not ruin, but balance, protection, and beauty. When you feel the warmth of summer sun on your face, or watch autumn's first leaves fall, you are witnessing the aftershock of an ancient catastrophe that became a gift. Every sunrise, every solstice, every migrating bird is part of a rhythm set in motion billions of years ago. The tilt that almost destroyed our world instead gave it texture, variety, and grace. From chaos came harmony. From collision came the cycle of life. The seasons are proof that even the most violent beginnings can yield the gentlest of patterns, that sometimes the universe must be shaken before it learns how to sing. When Earth's moon formed, it began a delicate gravitational dance. Its pull slows Earth's rotation over time, while keeping the planet's tilt stable enough for life to flourish. It began in fire. Around 4.5 billion years ago, a massive impact between the proto-Earth and a Mars-sized body, whom scientists call Theia, tore molten rock into space. For a brief moment, Earth wore a glowing halo, a ring of debris circling a wounded world. Over time, gravity coaxed that debris into a single body, the Moon. Born from chaos, it quickly became Earth's partner in balance, its silent guardian of motion. From the moment it formed, the Moon's gravity began tugging at Earth's oceans, pulling them toward it to create tides. These tides are not gentle, they move entire seas. As the water rises and falls, friction between the ocean and the seafloor dissipates energy, ever so slightly slowing Earth's rotation. Each day grows longer by mere milliseconds, every century, a change invisible to us, but vast over geologic time. Billions of years ago, a day on Earth lasted only about 6 hours. The Moon has been steadily stretching time itself. But this slowing spin comes with a trade. As Earth loses angular momentum, the Moon gains it. That extra energy pushes the Moon farther away, about 3.8 centimeters every year. If you could rewind time, the Moon would be far closer and the tides far stronger. If you fast forward, it will drift ever outward, its face growing smaller in our sky. Yet, even as it recedes, it maintains a perfect rhythm, locked in eternal synchrony. The same side of the Moon always faces us, its spin matching its orbit, a perpetual slow dance lasting billions of years. The Moon does more than raise tides. It stabilizes the Earth itself. Without it, our planet's axis could wobble wildly, swinging from near vertical to extreme tilts over millions of years. Such shifts would plunge the planet into chaotic climate cycles, devastating to life. But the Moon's gravitational presence acts as a gyroscope, keeping Earth's tilt steady around 23.5 degrees. It is this gentle stability that allows seasons to repeat predictably, giving ecosystems time to evolve, adapt, and thrive. Our Moon is not unique in this cosmic role. Across the solar system, moons serve as keepers of balance. Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto, orbit in resonant harmony, their mutual tugs heating their interiors and fueling volcanic and oceanic activity beneath their icy crusts. Saturn's moons sculpt its rings, their gravity shaping luminous arcs of dust and ice into patterns that shimmer like cosmic calligraphy. Each moon, in its own way, preserves motion, redistributes energy, and maintains equilibrium. In the distant future, the Moon's work will continue. Earth's rotation will slow until one day, perhaps billions of years from now, it becomes tidally locked, one side facing the Moon forever. The two will hang in space like an ancient couple at rest, their long dance finally still. But by then, their story will have already written itself into the fabric of life. Every tide that laps against a shore, every sunrise delayed by a heartbeat, every stable season that lets a forest grow, all trace their lineage to this celestial partnership. The Moon may be silent, but it speaks through the rhythm of the Earth, whispering through the waves and shadows. Our sun rotates once every 27 days at the equator. But it doesn't spin as one solid body. Different parts turn at different speeds, twisting magnetic fields into knots that erupt as solar flares. At the heart of our solar system burns a vast sphere of plasma, seething, luminous, alive. The sun is not a static ball of fire, but a dynamic engine of motion and magnetism. Its surface, the photosphere, churns like a boiling ocean of light. Beneath that surface, currents of charged gas rise and fall, carrying energy outward from the nuclear furnace at its core. And while it appears serene from 150 million kilometers away, the sun is, in truth, unlike a planet, the sun isn't solid. It's made entirely of plasma, gas so hot that atoms are stripped of their electrons, turning matter into a soup of charged particles. Because of this, its equator and poles rotate at different rates. The equator completes a spin roughly every 25 days, while the poles take closer to 35. This differential rotation stretches and distorts the sun's magnetic field lines, twisting them into enormous loops and spirals that can store unimaginable amounts of energy. Eventually, these tangled magnetic lines snap, releasing their pent-up energy as solar flares and coronal mass ejections, blinding bursts that fling charged particles across the solar system at millions of kilometers per hour. When these storms reach Earth, they stir our planet's magnetic field, painting auroras across the poles and sometimes disrupting satellites, radio waves, and power grids. From 150 million kilometers away, the sun's spinning heart still reaches us, shaping not just our light and warmth, but the invisible rhythms of technology and atmosphere. Yet this restless motion is also a sign of balance. The sun's spin helps regulate its magnetic cycles, flipping its magnetic poles roughly every 11 years. During these cycles, sunspots bloom and fade across its surface like freckles of fire, marking areas where magnetic energy concentrates. To us, these patterns are both beautiful and vital. They influence the strength of solar winds, the shape of our magnetosphere, and even the chemistry of Earth's upper atmosphere. Deep within the sun, closer to its core, the story continues in silence. Nuclear fusion fuses hydrogen into helium, releasing energy that takes thousands of years to reach the surface. Even here, motion defines existence. The plasma flows, rotates, and convects in enormous cells that shift over time. This internal spin maintains the sun's stability, countering gravity's endless pull with the pressure of light and heat. The sun's rotation also leaves fingerprints across the solar system. Its angular momentum is shared with the planets, influencing their orbits and magnetic orientations. The entire solar system, in a way, spins in sympathy with the star at its center. Each planet's motion is a note in the larger symphony of solar rotation, a harmony stretching across billions of kilometers. And though the sun's spin is slowing, it will never truly stop. As it ages, magnetic braking, the drag caused by its own stellar winds, steals tiny amounts of angular momentum, a process mirrored in stars across the galaxy. The sun is gently aging, turning more slowly with every million years, yet still glowing with the energy of birth. When you look up at daylight and feel its warmth, you are feeling motion made visible, rotation turned into radiance. The light on your skin began as a spark inside a spinning star, a ripple of energy born from a dance of plasma and gravity. The sun turns, and so do we. Its spin keeps the planets bound, its rhythm gives us time, and its restless motion sustains the fragile world that orbits in its glow. As stars spin, their magnetic fields coil like springs. When those fields snap, energy bursts outward, solar storms that can ripple through space and touch even the power grids of Earth. The sun is not simply a glowing sphere of fire, it is a living magnetic machine. Every twist, every turn, every rotation of its plasma builds tension within invisible magnetic lines that weave through its body. These fields are born deep within the solar interior, where vast rivers of charged particles flow in complex patterns. As the sun's equator spins faster than its poles, the magnetic lines stretch, twist, and tangle like threads in an ever-tightening braid. Eventually, the tension becomes too great. The magnetic lines snap and reconnect in violent outbursts of energy, a process known as magnetic reconnection. In an instant, energy equivalent to billions of atomic bombs is released, erupting from the sun's surface as a solar flare. These flares emit radiation across the electromagnetic spectrum, bursts of X-rays, ultraviolet light, and radio waves that surge outward through the solar system at the speed of light. But the most dramatic events are coronal mass ejections, enormous clouds of plasma hurled into space, carrying with them twisted loops of magnetic fields. They can weigh billions of tons and travel at millions of kilometers per hour, invisible until they collide with a planet's magnetic shield. When one of these storms reaches Earth, it compresses our magnetosphere like a drum being struck. Electric currents surge through the atmosphere, and the sky ignites in shimmering curtains of green, pink, and violet. The auroras, the Earth's luminous sigh in response to the sun's fury. These celestial light shows are more than decoration. They are visible proof that we live within a web of motion connecting star and planet. The same magnetic storms that paint the poles can also disrupt technology, short-circuiting satellites, confusing GPS systems, and even knocking out power grids on the ground. A single powerful flare could, in theory, disrupt global communications, a reminder that our modern world still lives in the shadow of the sun's ancient rhythm. And yet, these storms are not acts of rage, they are part of the sun's heartbeat. Every 11 years, the sun's magnetic field flips, and activity reaches a peak. Sunspots multiply, flares intensify, and solar winds grow stronger. Then, just as suddenly, the activity wanes, and the surface quiets again. It is a cycle of tension and release, a breathing pattern written in plasma and light. Other stars follow the same rhythm, their flares dwarfing even our suns. Some release superflares so immense they could sterilize entire planets. Yet this same magnetic dynamism is also a sign of vitality. A star that spins is a star that lives. As it rotates, its motion generates magnetism, and magnetism, in turn, shapes its behavior, its winds, and the environments of its planets. In this grand interplay of motion and magnetism, we see nature's duality: calm born from chaos, light born from tension. Our stars' storms are not signs of instability but of balance, energy stored, released, and renewed across cycles that span millennia. And though we may fear their power, these storms are also the reason we exist. They shape the space around us, shield us from cosmic rays, and remind us that motion, even when violent, is the universe's way of staying alive. Above the quiet Earth, the auroras shimmer like the memory of that cosmic motion, threads of light tracing invisible fields, whispers of a storm that began in the spinning heart of the sun. Inside atoms, electrons don't just orbit, they spin. That spin gives rise to magnetism and the rules of quantum behavior. Without it, light itself couldn't exist. When we think of light, we imagine brightness, a warm sunrise, a flickering candle, a distant star. But light isn't a substance, it's a consequence. It is the ripple of energy created by the restless motion of charged particles. Deep within every atom, electrons move in intricate, invisible patterns, each one carrying not only a charge, but a fundamental property called spin. This isn't spin in the everyday sense of rotation, but rather a quantum twist, a built-in angular momentum that defines how an electron behaves. Because electrons possess spin, they act like tiny magnets, creating their own miniature magnetic fields. When an atom absorbs energy, say, from heat, a collision, or a passing photon, its electrons jump to higher energy levels, but they can't stay there forever. When they fall back to lower levels, they release the stored energy as light. Each photon of light is born from the quantum transitions of spinning electrons. In essence, light is the language atoms use to release motion. The rules governing this process are delicate, precise, and absolute. Electrons with opposite spins can share the same atomic orbit, but no two electrons with the same spin can. This principle, known as the Pauli exclusion principle, gives matter its structure and stability. It determines how atoms bond, how molecules form, and how stars shine. If electrons didn't spin, or if they all spun in the same way, atoms would collapse. The entire fabric of matter and the light it emits would vanish. At a grander scale, this tiny spin-driven phenomenon becomes the foundation of the cosmos. Every gleam in the night sky, every sunbeam that touches your skin, is the result of electrons spinning in harmony with protons and nuclei, obeying invisible laws that convert motion into radiance. When a star fuses hydrogen into helium, it releases light because of these same quantum rules. The sun's glow, the fire in a match, the luminescence of distant galaxies, all trace back to the humble electron's spin. Even magnetism itself, so crucial to everything from compasses to galaxies, is a direct outcome of spin. When the spins of countless electrons align in a material, they create a magnetic field strong enough to move needles, generate electricity, and shape cosmic forces. The magnetic poles of planets, the auroras that dance across our skies, and the magnetized jets erupting from black holes all share this same origin in quantum spin. It's remarkable to realize that something so small, so abstract, gives rise to everything we see. The electron's spin bridges the gap between the invisible and the visible, the quantum and the cosmic. It is the silent mechanism through which the universe translates motion into light. So when you gaze at the stars, you are witnessing the grand sum of countless tiny spins working together across time and space. Every photon that reaches your eye carries the signature of an electron's twist, the fingerprint of motion frozen into brilliance. Light, in all its beauty, is nothing more than the universe's way of showing that even in stillness, everything is always turning. At the smallest scales, spin isn't motion through space. It's a fundamental identity. Electrons, protons, and neutrons each possess intrinsic spin, a kind of built-in twirl that defines how they interact. In the familiar world, spin means rotation, planets turning, wheels revolving, dancers pirouetting. But in the quantum realm, that meaning dissolves. Here, spin doesn't describe something physically turning in space, but a deeper property, one that determines how particles behave, combine, and even exist. It's as though every particle carries within it a secret rhythm, a whisper of angular momentum that exists even when nothing moves. Electrons, protons, and neutrons all possess this intrinsic spin, measured in units of the reduced Planck constant. Spin determines how particles align or repel, how atoms form, and how the forces of nature connect. It's not just a feature, it's a rulebook written into the code of reality. To the human mind, this can seem almost impossible to imagine. In the quantum world, particles behave both as points and as waves. Their spins can point up or down, but those directions have nothing to do with space as we know it. They are orientations in an abstract realm, a mathematical space of possibilities. When two particles meet, their spins decide whether they can coexist peacefully or must push each other apart. This is what gives matter its stability. Without spin, everything would collapse into an indistinguishable blur. Some particles, like electrons, belong to a class called fermions. Fermions obey the Pauli exclusion principle. No two can occupy the same state at the same time. This simple rule is the reason atoms have structure, why electrons arrange themselves into shells, why chemistry exists, why your body doesn't pass through a wall. Other particles, like photons, belong to a different class. Bosons. Bosons have integer spins and love to share space. They pile together, forming waves of light, fields of energy, and even the elusive fabric of gravity itself. Spin, in this sense, is the hidden architecture of existence. It determines which particles make up matter and which carry forces. It decides how the universe communicates with itself, how light travels, how magnetism flows, how energy transfers from one form to another. Even the act of observation, one of quantum mechanics' strangest mysteries, is influenced by spin. When scientists measure a particle, its spin collapses from a cloud of probabilities into a definite state, as if reality itself chooses a direction to face. In laboratories, we've learned to harness this invisible motion. Spin gives rise to magnetic resonance, the principle behind MRI scans that let us peer inside the human body without harm. It powers quantum computers that store information in spin states, up and down as binary code written in the language of nature. The technology of the future may depend entirely on mastering these quantum twirls. And yet, spin remains one of physics' quietest mysteries. It has no moving parts, no mechanical analog, and yet it produces magnetism, stability, and light. It is motion without movement, rotation without rotation. Perhaps, in its strange elegance, it reveals something profound, that motion is not always something things do, but something they are. At the smallest scales, the universe hums with this hidden rotation. Every particle, every atom, every beam of light carries its own subtle spin. Together, they form a cosmic orchestra of motion, so intricate and small that we cannot see it. But without it, nothing larger could exist. The universe spins not only through space, but within itself. Quantum spin governs chemistry, bonding, and even the structure of matter. The shape of everything, from water molecules to DNA, depends on how these invisible spins align or oppose. Spin is not just a subatomic curiosity, it is the quiet architect behind all that is solid, liquid, or living. When electrons circle atomic nuclei, their spins act like tiny magnetic arrows. Whether these arrows point together or in opposite directions determines how atoms bond, how molecules form, and ultimately, how the tangible world comes into being. The difference between stable matter and chaos, between metal and gas, between water and air, begins with the way those spins arrange themselves in the quantum dark. Take the simplest example: the hydrogen molecule. Two hydrogen atoms can only bind because their electrons have opposite spins. If both spins pointed the same way, the atoms would repel, their wave functions forbidden from overlapping. But because their spins oppose, the electrons can pair, their clouds merging into a shared orbit. That pairing releases energy, forming a bond, the same type of bond that builds every molecule you've ever touched. Without opposite spins, chemistry itself would not exist. This pairing principle, repeated across countless atoms, gives rise to the complexity of life. The spiraling lattice of DNA, the crystalline arrangement of salt, the fluid flexibility of water, all emerge from quantum spin symmetry. When electrons align, they generate magnetism. When they oppose, they create balance. Spin determines whether a material is magnetic or non-magnetic, conductive or insulating, reactive or inert. It even decides how heat and electricity move through solids. Every chemical reaction, every spark, breath, and heartbeat depends on how spins exchange their orientation. On a grander scale, the influence of spin reaches far beyond the laboratory or the human body. In the hearts of stars, spin dictates how atomic nuclei fuse, transforming hydrogen into helium and releasing the energy that fills galaxies with light. The forces that govern the atomic nucleus, the strong and weak nuclear forces, are deeply tied to spin interactions, deciding how matter changes, decays, or endures over time. Even the way particles feel gravity or electromagnetism is coded into their spin. And yet, spin is not rigid, it dances. Inside magnetic materials, the spins of trillions of electrons align into domains, their orientations rippling like waves through the metal. Scientists call these ripples spin waves or magnons, and they behave almost like particles themselves, quantized vibrations of alignment. In the future, we may use these waves to transmit information, replacing electrons with pure spin. This emerging field, spintronics, promises technology that operates faster, cleaner, and closer to the language of the universe. It's astonishing to think that everything visible, the curve of a planet, the structure of a leaf, the shimmer of a metal, is built upon something invisible, something that doesn't even spin in the traditional sense. And yet, quantum spin is the scaffolding of form, the foundation of behavior, the logic beneath beauty. In the deepest sense, spin is the law that holds reality together. It dictates the stability of atoms, the order of the elements, and the possibility of life. If the spins of electrons did not balance just so, there would be no molecules, no stars, no minds to wonder about either. Every structure we see, from the smallest crystal to the largest organism, is a reflection of quantum alignment, microscopic spins arranging themselves into macroscopic harmony. The universe is not random, it is tuned, layer upon layer, by the smallest of motions. Invisible spins shape visible worlds, and in their endless balance, the laws of reality are written. Too much spin, and a collapsing star can't form. Too little, and gravity wins completely. The universe balances between these extremes, a precise tension that allows structure to exist at all. Across the cosmos, creation and destruction are constantly at play. Gravity pulls inward, seeking collapse. Motion, particularly spin, pushes outward, resisting it. Between these two forces lies the narrow equilibrium that gives rise to stars, planets, and galaxies. Without this cosmic compromise, the universe would either tear itself apart or fall into a featureless abyss. Every structure we see, every shining sun, every orbiting world, is the fragile product of that balance. When a cloud of gas begins to collapse under its own gravity, its particles move closer together, and its spin increases. If that rotation becomes too rapid, centrifugal force overpowers gravity, preventing further collapse. The cloud may fragment, breaking into multiple stars or drifting apart entirely. But if there is too little spin, gravity dominates, crushing matter into a singular point or a black hole. The same principle governs everything from the formation of galaxies to the orbit of electrons. In spiral galaxies like our Milky Way, rotational motion keeps billions of stars in stable orbits around their center. Were the galaxy to spin faster, its stars would fling outward into intergalactic space. Were it slower, gravity would draw them inward, collapsing the system into chaos. The elegant spirals we admire in deep space photographs are not static structures, but snapshots of perfect balance, a delicate choreography between gravity's hunger and motion's grace. Even on the scale of stars, balance rules all. A star forms when the inward pull of gravity compresses matter until nuclear fusion begins at its core. That fusion creates outward pressure that pushes back against collapse. Too much spin, and the star would tear itself apart. Too little, and it would collapse faster than fusion could sustain it. The serene glow of starlight, then, is not peace, it's equilibrium, a tension held steady for millions or billions of years. Black holes, too, play by these rules. A spinning black hole, or Kerr black hole, carries immense angular momentum. That rotation prevents total collapse, creating an event horizon that twists space and time itself. If it spins too quickly, theory suggests it could even expose its singularity, something forbidden by the laws of physics. Once again, the universe steps in, enforcing balance, ensuring that even the most extreme objects stay within the bounds of cosmic law. From the largest galaxies to the smallest atoms, this balancing act is everywhere. Electrons stay bound to nuclei because their quantum motion perfectly counteracts electromagnetic attraction. Planets orbit their stars in stable ellipses because their velocity offsets the pull of gravity. Even you, sitting on Earth, are part of this equilibrium, as the planet's spin gently counters the sun's pull, holding you steady in space. It's easy to forget that the universe, for all its vastness, is exquisitely precise. The balance between motion and gravity is not an accident. It's the only reason anything endures. Stars are born and die, galaxies collide and reform, and yet the grand equation remains constant. Every sunrise, every orbit, every rotation is an act of balance, a negotiation between falling and flying, too much or too little, and existence unravels. But here we are, in the quiet middle ground where the two forces meet, where creation can breathe. And in that perfect tension, life finds room to exist. When massive stars die, their cores collapse into singularities that trap light. But they keep their spin, twisting space and time around them in an invisible vortex called frame dragging. Few objects in the universe are as mysterious or as elegant as a spinning black hole. It is the ultimate fusion of gravity and motion, a place where the known laws of physics blur into something deeper, stranger, almost poetic. A black hole is not an object in the traditional sense. It is a region of space where gravity is so strong that nothing, not even light, can escape. Yet, for all its darkness, it is defined by a kind of eternal motion, a spin inherited from the dying star that birthed it. When a massive star exhausts its nuclear fuel, gravity begins its final conquest. The outward pressure that once supported the star fades, and the core collapses inward under its own immense weight. As it does, the law of angular momentum takes command. As the collapsing material shrinks, it spins faster, conserving motion the way an ice skater does when pulling in their arms. The collapse continues until matter itself can no longer resist. The star becomes a singularity, a point of infinite density, and the spin, impossibly fast, remains. This spin does not stay confined within the black hole. It reshapes the very fabric of space-time around it. According to Einstein's theory of general relativity, mass curves space, but rotation drags it. Near a rotating black hole, space-time is literally twisted, forced to spin along with the black hole's rotation. This effect, known as frame dragging, creates a region called the ergosphere, a zone outside the event horizon where nothing can remain still. Everything, even light, is compelled to swirl around the black hole like leaves caught in a whirlpool. Within this maelstrom, matter falls inward, spiraling at nearly the speed of light. As it does, it heats up, releasing enormous amounts of energy. Paradoxically, the area around black holes can be some of the brightest regions in the universe. Accretion disks, rings of hot gas orbiting just outside the event horizon, blaze with radiation, powered by friction, compression, and the relentless pull of gravity. From these infernos emerge relativistic jets, colossal streams of plasma ejected at near light speed, shooting thousands of light years into space. Scientists believe it's the black hole's spin that powers these cosmic engines, channeling rotational energy into the universe itself. Spinning black holes are categorized by their spin parameter, a measure of how much angular momentum they carry. Some rotate gently, others nearly at the speed of light. The most extreme among them, called maximally spinning or Kerr black holes, twist spacetime so violently that even time slows differently depending on direction. To fall into one would be to enter a reality where forward and backward, future and past, lose meaning. Astronomers have observed this phenomenon not only theoretically but visually. The Event Horizon Telescope's historic image of the black hole in galaxy M87 revealed the glowing ring of light bent by its spin, a cosmic whirlpool frozen in time. What we see in those images is not the black hole itself, but the trace of its motion, the dance of light skirting the edge of oblivion. And yet, even in their violence, black holes are not destroyers. They are transformers. The spin they preserve continues the universe's legacy of motion, converting collapse into power, chaos into structure. They regulate galactic evolution, shaping the stars and matter that orbit them. A spinning black hole is the purest expression of the universe's first rule. Nothing ever truly stops moving. Even in death, a star's rotation lives on, warping time, sculpting light, and whispering through the cosmos that motion is eternal. In the silent dark at the center of galaxies, the universe remembers its own turning. Near a spinning black hole, the very fabric of space-time begins to rotate. Anything caught nearby, light, gas, even time, must follow the whirl. It's one of the most astonishing ideas in all of physics. Space and time are not just passive backdrops upon which the universe plays out. They are living, malleable entities. They can stretch, bend, and twist under the influence of gravity. And around a spinning black hole, they do something even stranger. They rotate. Imagine a whirlpool, not of water, but of reality itself. As the black hole spins, its immense angular momentum drags the surrounding space-time into motion, forcing everything nearby to turn with it. This phenomenon, known as frame dragging, is not limited to matter. It affects light, magnetism, and even the flow of time. The closer you approach the black hole, the stronger the effect becomes, until eventually, motion itself loses its meaning. There is no standing still near a spinning singularity. There is only turning, faster and faster, into the dark. This region of swirling space-time is called the ergosphere, a zone that exists outside the event horizon. Within it, space is pulled around the black hole so violently that no object can remain stationary. A spaceship attempting to hover would find itself inexorably drawn into rotation, carried along by the tide of space-time itself. Only by moving in the direction of the spin could it hope to resist. In the ergosphere, the distinction between motion and stillness dissolves. The universe itself is moving. But the ergosphere also holds a strange opportunity. Because it lies outside the event horizon, it is still connected to the rest of the universe. The rotational energy of the black hole can, in theory, be extracted. This process, first proposed by physicist Roger Penrose, involves sending an object into the ergosphere and splitting it in two, one piece falling into the black hole, the other escaping with more energy than it entered. It's as though the rotation of space-time itself can be mined, converting the black hole's spin into usable power. In principle, this mechanism could explain how black holes drive some of the brightest phenomena in the universe, including the colossal jets that blast from galactic cores. Even here on Earth, we can measure faint echoes of this cosmic effect. Satellites orbiting our planet have detected minute frame dragging caused by Earth's own rotation, a gentle twist in space-time predicted by Einstein's general relativity. It's vanishingly small compared to what occurs near a black hole, but it proves the same truth. Rotation shapes the very geometry of the universe. What happens if you could fall into such a region? As you approach a spinning black hole, light itself begins to curve, bending into spirals. Time dilates, seconds for you become centuries for the rest of the cosmos. From the outside, it looks as if you're moving slower and slower, frozen at the edge. But from within, you would experience the universe as a torrent of motion. Everything spinning, bending, stretching around you. At the edge of these spinning abysses, reality becomes a fluid. It behaves not like a void, but like a storm, one made not of wind or water, but of space and time. The black hole's spin has no surface, no texture, and yet it moves entire galaxies, powers jets of radiation, and determines the evolution of cosmic structures millions of light years away. When we say the universe is spinning, we don't just mean its planets and stars. Even the stage they dance upon turns with them. Space is not silent. It whirls, ripples, and flows, carrying matter and light in an unending current. Around black holes, the universe doesn't just contain motion, it is motion. At the hearts of most galaxies lie supermassive black holes. Their furious spin drives jets of energy, thousands of light years long, sculpting entire galaxies into shape. Every galaxy, no matter how vast or luminous, has a heart, a region of extraordinary gravity and unimaginable motion. At that heart waits a supermassive black hole, containing millions or even billions of times the mass of our Sun, compacted into a point no larger than a star. It is not a dead remnant, but a living engine, its spin feeding and shaping the galaxy around it. When matter falls toward one of these giants, it doesn't simply vanish. The gas and dust spiral inward, forming an accretion disk that glows brighter than all the stars of the galaxy combined. Friction, Magnetism and gravity combine in this spinning maelstrom, heating the material to millions of degrees. The faster the black hole spins, the more energy it can extract from the infalling matter. Near the event horizon, the spinning field of space-time acts like a dynamo, twisting magnetic lines into tight, coiled springs of unimaginable strength. When these magnetic coils snap, they release torrents of plasma that blast outward along the black hole's rotational axis, jets that can stretch across intergalactic space, thousands or even millions of light-years long. These jets shoot out at nearly the speed of light, piercing the darkness, injecting energy into the surrounding galaxy and beyond. They illuminate radio waves, X-rays, and gamma rays across the cosmos, visible to telescopes billions of years later. It's a paradox of cosmic scale. The most destructive force in nature gives rise to breathtaking order. These spinning black holes regulate the birth of stars in their host galaxies. When their jets fire, they push away the gas clouds that might otherwise collapse into new stars, slowing star formation. When the jets quiet, the gas cools and condenses once again. The rhythm of a galaxy's life, its growth, its shape, its balance, depends on the heartbeat of its central black hole. Our own Milky Way has such an engine. Sagittarius A star, a supermassive black hole about 4 million times the mass of the Sun. Though currently quiet, it too spins, its presence guiding the dance of stars around it. Astronomers have tracked these stars in orbit, moving so swiftly near the center that they confirm an invisible mass of staggering density. Occasionally, a wandering cloud or star will venture too close, and for a brief moment, Sagittarius A star flares as matter spirals inward and is devoured by the spinning abyss. Across the observable universe, the pattern repeats. Some galaxies blaze as quasars, supermassive black holes spinning and feeding so fiercely that they outshine entire clusters of galaxies. Others emit vast radio lobes, the lingering footprints of ancient jets still echoing through intergalactic space. In every case, spin is the architect. The faster the rotation, the greater the energy released, and the more profound the black hole's influence. It's tempting to think of these cosmic engines as isolated monsters, but in truth, they are collaborators in creation. Without them, galaxies might never have formed their elegant spirals or stable cores. Their spinning hearts keep the cosmic ecosystem in balance, ensuring that energy flows between birth and decay, chaos and order. When we gaze at a galaxy through a telescope, we are not just seeing billions of stars. We are witnessing a sculpture carved by rotation and gravity, powered by a single spinning heart in the dark. The next time you see an image of a galaxy, imagine it breathing, pulsing, alive, and remember that somewhere at its center, a black hole turns in perfect silence, shaping the universe with every spin. The Milky Way turns once every 230 million years. Stars within it orbit like beads in a whirlpool, each bound by the shared momentum of billions of suns. When we look up on a clear night, the Milky Way appears as a soft river of light stretching across the sky. Yet what we see is only a small fraction of a vast spiral, an immense, rotating disk, 100,000 light-years wide, containing hundreds of billions of stars, planets, and clouds of glowing gas. And like a great cosmic wheel, it is spinning, slowly but relentlessly, completing one revolution in the time it takes our Sun to orbit its center, a journey of 230 million years. Every star, every planet, every fragment of dust participates in this grand motion, bound together by gravity's unseen hand. This rotation is not chaotic, it is organized, graceful, and precise. The Milky Way's spiral arms are not rigid structures, but patterns of density, like the crests of waves moving through water. Stars drift in and out of these arms as they orbit the galactic core, entering regions of higher density where gas clouds are compressed, triggering new generations of stars. These bright newborns illuminate the spiral patterns, marking the pathways of motion across the galactic disk. At the center of it all lies Sagittarius A star, the supermassive black hole whose spin and gravity help anchor the entire structure. Around it, Stars whirl at breathtaking speeds, some traveling thousands of kilometers per second. Farther out, the spiral arms curve gently through the galactic plane, their motion slower but steady. The balance between gravitational pull and rotational velocity ensures that the galaxy neither collapses inward nor flies apart. It is, once again, the same cosmic balancing act, gravity's pull and angular momentum's resistance locked in eternal partnership. But there is a mystery in this rotation. When astronomers measured the speeds of stars at different distances from the galactic center, they found something unexpected. Stars far from the core were moving faster than they should be. According to the visible matter alone, they ought to drift more slowly, pulled less tightly by gravity. Instead, they sped along as if some unseen mass were holding the galaxy together. This invisible substance, what we now call dark matter, appears to envelop the Milky Way in a vast halo, providing the extra gravitational glue that maintains its spin. Without this hidden mass, the spiral might unravel. The fact that it does not is proof that the galaxy's motion is governed not only by what we can see, but by the unseen structure of the cosmos itself. Every star's orbit is a negotiation between light and shadow, visible and invisible, known and unknown. Galaxies like the Milky Way are not alone in this cosmic choreography. Across the universe, spiral galaxies turn like vast pinwheels, their luminous arms curling through the dark. Some spin rapidly, their centers blazing with activity. Others turn slowly, diffuse, and quiet. Even irregular and elliptical galaxies, those lacking the perfect symmetry of spirals, retain rotation, the memory of ancient collisions and mergers that shaped them. From a cosmic distance, each galaxy is like a single whirlpool in an ocean of motion, part of a larger flow that connects everything. Our galaxy is not fixed in place. It drifts through space, carried by the gravitational tides of the local group of galaxies, all orbiting one another in a dance that spans millions of light years. And so, the spiral continues, order carved from chaos, light born from motion. The Milky Way's turn is slow beyond imagination, yet in that slow turning lies everything we know: the birth of stars, the shaping of worlds, the rhythm of cosmic time. To live within a galaxy is to ride the spiral itself, to move, silently and forever, through a universe that never stops spinning. Though we can't see it, dark matter spins too. Its gravitational pull shapes the spiral arms of galaxies, acting as the hidden conductor of cosmic motion. The galaxies we see, brilliant spirals glowing across the night, are only half the story. Their elegance and symmetry, their stable rotation and structure depend on something we cannot see, touch, or detect directly. Surrounding each galaxy is an enormous, invisible halo of matter that neither emits nor reflects light. This is dark matter, a ghostly substance that outweighs all visible matter in the universe by a factor of 5. Though it reveals itself only through gravity, it is the quiet architect behind every spinning galaxy. Dark matter does not shine, but it sculpts. It forms a vast, three-dimensional web across the cosmos, a lattice of invisible filaments stretching for billions of light years. At the intersections of this web, galaxies form, drawn to the densest knots of dark matter. Without it, the universe as we know it would have no structure. The Milky Way, the Andromeda Galaxy, every cluster and supercluster, they are all suspended within halos of dark matter, rotating inside them like fireflies trapped in glass spheres. We cannot see dark matter spin, but we can feel its influence. When astronomers measure the rotational speeds of stars within galaxies, the math doesn't add up. The outer stars are moving too fast. If only visible matter existed, they should fly away into intergalactic space. Instead, they remain bound, orbiting as though an unseen hand were holding them in place. That hand is dark matter, its gravity distributing momentum evenly across the galaxy, ensuring the spiral remains intact. Simulations of the early universe show how this works. In the first few 100 million years after the Big Bang, dark matter began to clump together under gravity, forming the seeds of galaxies. As it gathered, it spun. These halos of invisible matter rotated slowly, pulling in gas and dust that would eventually ignite into stars. Every visible galaxy we see today, every pinwheel of light, is shaped and stabilized by this hidden rotation, the silent spin of dark matter beneath. And though we call it dark, dark matter may not be still. Many cosmologists suspect it possesses its own subtle angular momentum, swirling in vast halos, each with its own unique rotation profile. These rotations determine how galaxies align, how they merge, and how they drift through the cosmic web. Some evidence even suggests that entire clusters of galaxies may spin together, linked by filaments of dark matter that twist space on scales too vast for us to comprehend. This invisible spin could be the universe's most fundamental motion, one that existed before light, before stars, before atoms themselves. If normal matter dances to the rhythm of gravity, then dark matter is the musician, playing a song we can only hear in its echoes. Every beam of light from a distant galaxy bends slightly as it passes through dark matter's gravitational field. We can map those distortions, tracing the outlines of the unseen. From these maps, we see that dark matter doesn't just exist, it moves, flows, and spins, carrying the entire luminous universe in its current. Perhaps that's the deepest truth of all, that what we call darkness is not absence, but foundation. It is the framework that holds the stars, the silent vortex beneath the spiral. Galaxies are not free-floating islands. They are sails caught in invisible winds, moving in harmony with a cosmic tide we are only beginning to understand. Somewhere beyond sight, dark matter turns. Its invisible spin is the steady heartbeat of the universe, unseen yet undeniable, the quiet force that keeps everything from drifting apart. Even the universe's expansion isn't perfectly straight. Gravitational interactions between galaxies cause subtle rotations, slow pirouettes of entire clusters across cosmic time. When we picture the universe expanding, we often imagine galaxies racing away from each other in perfect symmetry, and even stretching of space in every direction. But the cosmos is never perfectly uniform. Its expansion, while grand and relentless, carries tiny ripples and distortions, gravitational imbalances that twist, tug, and turn. These subtle imperfections, seeded in the earliest moments after the Big Bang, give the universe its structure. Gravity, that patient sculptor of motion, ensures that expansion is never a simple outward push. As galaxies form along the cosmic web, those vast filaments of dark matter and gas, they tug on one another, transferring angular momentum through invisible threads of gravity. Clusters of galaxies begin to turn slowly, like leaves swirling in an unseen current. Over billions of years, this gravitational interplay generates colossal rotations, pirouettes so vast that they span millions of light-years, yet unfold at a pace almost beyond imagination. Recent observations hint at this quiet cosmic choreography. Astronomers studying the large-scale structure of the universe have found evidence that galaxy clusters may indeed spin. Entire filaments, vast chains of galaxies, appear to twist along their axes, rotating like cosmic corkscrews. These motions are extraordinarily slow. A full rotation might take tens of billions of years. Yet across the eons, their cumulative effect shapes the flow of matter, guiding galaxies into intricate spirals and arcs. At smaller scales, this twisting manifests in galactic mergers and alignments. When two galaxies pass close enough, their mutual gravity can set them spinning around a shared center of mass. Sometimes they merge, forming new galaxies that inherit their combined angular momentum. Other times, the interaction flings stars and gas outward, sculpting tidal streams that trace the flow of spin through intergalactic space. Even in collision, the universe preserves motion. It transforms linear chaos into rotational grace. The cosmic expansion itself, meanwhile, is not perfectly smooth. The accelerating push of dark energy drives galaxies apart, while gravity fights back, binding local regions together. Where these forces meet, small shears and rotations emerge in the very fabric of space-time. Astronomers call this cosmic shear. subtle distortions in the light of distant galaxies that reveal how mass bends and twists space as the universe expands. Through these faint signals, we glimpse the universe's rotational fingerprint written across the sky. If we could see the cosmos in its entirety, not just stars and galaxies, but the invisible scaffolding of dark matter and energy, we might find that everything is moving not just outward, but around. A grand spiral, written into expansion itself. The same spin that shapes atoms and stars might echo at the scale of the entire universe, repeating the same pattern across infinite magnitudes. This idea that rotation exists at every level, from the quantum to the cosmic, is one of nature's most beautiful symmetries. It suggests that motion is not an accident, but a universal principle, embedded in the geometry of space and time. Even as the universe stretches ever outward, its expansion curves, ripples, and dances, as though guided by the faint memory of its first spin. So when we say the universe expands, we should not imagine a simple explosion, but a graceful unfolding, a spiral of galaxies, filaments, and clusters turning together in slow, eternal rhythm. The cosmos is not only growing, it's twisting. Expansion and rotation are not opposites. They are partners in creation, shaping the tapestry of space into the dynamic, living universe we call home. If we could translate rotation into sound, the universe would hum in deep, resonant tones. Each planet, star, and galaxy contributes its own vibration to the cosmic symphony. In the vacuum of space, no air exists to carry sound waves. Yet, in another sense, the universe is never silent. Every rotation, every vibration, every flicker of energy leaves a pattern, a rhythm that, if we could hear it, would become an endless song. From the smallest quantum spin to the turning of galaxies, motion ripples through the fabric of space-time, setting the cosmos gently vibrating in frequencies far beyond the reach of our ears. Astronomers have found ways to listen to this hidden music. When black holes collide, they send out gravitational waves, ripples in space-time that stretch and compress reality itself. These waves travel through the universe at the speed of light, like chords struck upon the strings of creation. When detectors such as LIGO and Virgo record them, they convert those distortions into sound. What we hear is haunting, a deep, rising chirp as two black holes spiral inward and merge, releasing more energy in a moment than all the stars in the observable universe combined. It is the sound of motion made pure, the universe ringing like a bell. Even the sun sings. Its surface roils with convection, creating waves that travel through its interior. Astronomers study these oscillations through a field called helioseismology, translating the sun's trembling into tones. The result is a constant low-frequency hum, a reminder that even the calmest light hides restless motion. Other stars, too, have their own harmonies. Giant stars pulse like beating hearts, their surfaces rising and falling in slow rhythms that can last for days or years. Each vibration carries clues about the star's internal structure, its density, and its age. Planets have their songs as well. When the Voyager spacecraft flew past Jupiter and Saturn, it recorded the electromagnetic waves produced by their magnetospheres. Converted into sound, they revealed eerie, shifting choirs of plasma and magnetic resonance, a natural music born of rotation, magnetism, and solar wind. Earth sings, too, the whisper of its magnetosphere interacting with solar particles, the rumble of earthquakes, the resonance of the oceans moved by tides. If we could hear the planet from space, its song would be a blend of slow rhythms and atmospheric sighs, modulated by its spin. At the larger scales, the entire universe vibrates with low-frequency gravitational tones, waves left over from the earliest moments of the Big Bang. These primordial oscillations, though faint, still echo through space, creating a cosmic background hum that scientists call the stochastic gravitational wave background. It is the universe's memory of its own beginning, the faint aftersound of its birth. If we could amplify these vibrations into sound, the cosmos would not roar, it would resonate, deep sustained tones would blend with lighter harmonics, forming an ever-shifting symphony of motion. Galaxies would provide the bass notes, stars the melodies, planets the intricate percussion. Black holes would punctuate the silence with thunderous, fleeting booms, while dark matter's unseen waves would hum beneath it all. Steady and mysterious. In truth, the universe may be the grandest orchestra of all, its instruments made of matter, energy, and gravity, its music composed of motion and time. Every atom spins, every planet turns, every galaxy whirls, and together they create harmony from chaos. And though our ears cannot hear it, some part of us still feels it, the resonance of existence itself, vibrating quietly through everything we are. The next time you look at the stars, imagine the music behind the silence, the turning of galaxies, the trembling of atoms, the endless hum of motion. This is the sound of spinning space. Over billions of years, friction and tidal forces drain energy from rotation. Planets slow, stars dim, and galaxies drift apart, but angular momentum ensures nothing truly stops. Every spin in the universe carries a cost. Though motion seems eternal, every turn leaves a trace of its energy behind, whispered away as heat, light, and gravitational waves. Slowly, imperceptibly, the cosmos ages. The planets spin more languidly, stars burn through their fuel, and the great structures of the universe drift farther apart. Time itself becomes a kind of friction, smoothing out the rough edges of motion until only faint echoes remain. On Earth, the process is subtle but measurable. The moon's pull on our oceans creates tides that drag against the planet's rotation. As the water rises and falls, it transfers energy outward, slowing Earth's spin ever so slightly. 1 billion years ago, a day was only 18 hours long. Now, it's 24. Each sunrise carries a fraction more stillness than the one before, a quiet record of time's invisible hand. Stars, too, surrender their motion to age. But as they emit stellar winds, streams of charged particles that flow into space, they lose angular momentum. Over millions of years, their spin slows, and their magnetic fields weaken. The fiery turbulence of youth gives way to calm stability, and eventually, to silence. The sun itself, now middle-aged, spins more slowly than it once did, shedding its energy gently into the solar wind. In a few billion years, when it swells into a red giant, its rotation will slow even further, until only its glowing core remains, a white dwarf, cooling in stillness. Even galaxies, those vast whirlpools of billions of stars, are not immune. Though they rotate on scales almost beyond comprehension, their energy disperses over time. Collisions between galaxies, once dramatic, fiery events, will become rare as the universe expands. The gravitational glue that binds them weakens as dark energy accelerates the cosmic expansion. One day, the Milky Way and its neighbors will drift apart so far that their motion relative to one another becomes frozen, locked by distance and entropy. And yet, the story doesn't end there. Angular momentum, that ancient law of motion, forbids true stillness. Even as rotation slows, its essence persists. A spinning planet may lose its speed, but it transfers that momentum to its moon, its orbit, or the faint gravitational ripples it sends through spacetime. Motion is never destroyed, only redistributed, scattered across the cosmos in ever finer patterns. In the far future, stars will fade, galaxies will dim, and the universe will grow cold. The great engines of motion, black holes, neutron stars, and quasars, will exhaust their fuel, radiating away their last traces of spin. Black holes themselves will evaporate through a process known as Hawking radiation, releasing their energy in the faintest size of light. Even then, something will remain. The background hum of rotation's memory, a universe filled with particles and waves, still carrying the faintest spin. It is a strange comfort to know that nothing truly stops. Motion is eternal, but not in form, It evolves, softens, and diffuses like the fading echo of a bell. Every revolution, every orbit, every cosmic turn leaves a mark that endures long after the object itself is gone. Someday, in the farthest future imaginable, when the last star has gone dark and the galaxies have scattered into the void, the universe will still remember how to move. Its final act will not be stillness, but serenity, the slow, quiet turning of existence itself, fading not into silence, but into peace. One day, far into the future, Earth's rotation will synchronize with the Moon. Our planet will show only one face to its companion. Days will last forever. This is the slow destiny written in the tides. Every day, the Moon's gravity pulls on Earth's oceans, raising bulges of water that slide across the surface as the planet spins. Those tides don't return all the energy they borrow. They drag slightly behind the Moon, creating friction that transfers a trace of Earth's rotational momentum to its orbit. The Moon gains distance, Earth loses speed. It's a cosmic trade that has been happening for billions of years, so gradual that it's nearly invisible, yet its consequences stretch into eternity. Today, Earth rotates once every 24 hours, while the Moon orbits once every 27 days. But the two are locked in a long gravitational negotiation. As Earth slows, the Moon drifts farther away, roughly 4 centimeters per year. Eventually, this exchange will reach its natural conclusion. Earth will rotate so slowly that one side will always face the Moon, just as the Moon already presents the same face to us. The two will become tidally locked, forever turning together in a slow, unbroken waltz. When that day comes, a single hemisphere of Earth will bask in constant moonlight, while the other will never see the Moon again. The familiar rhythm of day and night will fade into something alien. Half the planet will live in eternal twilight, its skies fixed with an unmoving moon, while the other half will experience the same skyless stillness we see from the far side of our lunar companion. The tides will quiet. The oceans will no longer breathe in and out. Their motion will settle into vast, slow currents that move with the planet's new equilibrium. It won't happen soon. Scientists estimate that this final locking will take tens of billions of years, long after the Sun has exhausted its fuel and expanded into a red giant. Earth, by then, may already be scorched or consumed, its seas boiled away, its continents reduced to dust. And yet, the physics remains certain. The process is inexorable, written into the mathematics of gravity and motion. The Earth will slow and the Moon will drift, until both are frozen in mutual gaze, caught in the stillness of perfect balance. But even this stillness is not truly still. The pair will continue to orbit the Sun, moving together through space as one. Their locked rotation will remain a form of motion, a continuation of the spin that began in the dawn of the solar system. Angular momentum cannot die. It only changes form. This distant stillness, then, is not the end of movement, but its softest expression. The same forces that once made waves crash, winds blow, and days turn will one day yield a perfect symmetry. No rising moon, no setting sun, just the hush of balance. And in that quiet, the Earth and Moon will remain, two celestial partners forever holding each other's gaze, still turning together through the infinite dark. The tides will be gone, the winds calm, the sky unchanged, but the motion, the memory of it, will remain in the very fabric of space itself. Even when the day no longer comes, the universe will still be moving. Every rotation carries history. From atoms to galaxies, spin encodes the story of how matter once moved, collided, and merged. It is the language of cosmic inheritance. In a universe without memory, motion would be meaningless. But every particle, planet, and star remembers. Their spins are not random, they are relics, fossil imprints of the forces that shaped them. The direction of a planet's rotation, the tilt of a star, the spin of an electron, all of it whispers a story about the collisions, compressions, and cosmic encounters that forged them. Spin is not just motion, it is the record of motion, a kind of memory etched into matter itself. When our solar system formed, a vast cloud of dust and gas collapsed under its own gravity. As it did, it began to rotate, conserving its angular momentum. Every atom, every grain of dust within that cloud, contributed to the spin that now drives the orbits of planets, the turning of moons, and the swirling of our sun. The Earth's rotation, our 24-hour day, is an echo of that original movement, an ancient rhythm that began before the planet even existed. We live inside a memory written in motion. The same is true for galaxies. Their majestic spirals did not emerge by chance. They are shaped by the accumulated spins of countless stars and dark matter halos, combined and refined through time. When galaxies collide, their spins tangle and merge, creating new structures, new orientations. The resulting galaxy carries both the chaos and the harmony of its ancestors, a living archive of cosmic evolution. Even at the smallest scales, spin holds the same legacy. The electron's intrinsic spin, though not a literal rotation in space, defines how it behaves, bonds, and aligns with other particles. This microscopic spin is ancient, unchanged since the earliest moments after the Big Bang. When two electrons pair in an atom, their opposite spins lock in balance, mirroring the same harmony that governs the orbits of planets and stars. Across scales and magnitudes, the pattern repeats, motion giving rise to structure, and structure preserving motion's story. Spin is also how the universe remembers change. When two stars merge, their spins combine to form something new, conserving angular momentum while carrying traces of their pasts. When a collapsing star becomes a neutron star or black hole, its spin increases dramatically, compressing billions of years of rotation into a single, dizzying turn. In these objects, the universe compresses its own history, spinning faster as it remembers more. Perhaps that's why so much of the cosmos seems to move in circles, cycles, and spirals. Every orbit, every turn, is a kind of remembrance, a way for the universe to keep continuity between what was and what is. Rotation ensures that energy never fades completely, that the echoes of creation are carried forward through time. In this sense, spin is not just a physical property, it's a storyteller. Every turn of a planet, every flicker of a pulsar, every twisting magnetic field is a word in the cosmic language of motion. Together, they form a narrative billions of years long, written not in ink or sound, but in momentum and gravity. So when we gaze into the night sky, we're not just looking at stars, we're looking at the memories of the universe, still spinning. Each glimmer carries a record of its birth. Every orbit traces an unbroken thread to the beginning of time. The universe remembers not through words, but through motion. And so long as something turns, its story will never truly end. Even humans are born of rotation. The swirling disks that formed stars also birthed the molecules in our bodies. The atoms in your blood once belonged to a spinning star. Every part of us carries the echo of that cosmic motion. Long before there was life, before Earth even existed, clouds of hydrogen and helium spun through space, collapsing into the first generation of stars. Within those stars, nuclear fusion began, the churning, spinning cauldrons where simple atoms were forged into complex ones: carbon, oxygen, iron. When those stars reached the end of their lives, they exploded, scattering their elements across space in vast rotating clouds once again. From those clouds, new stars and planets formed, including our sun and our world. The rotation that sculpted them never disappeared. It became part of everything, from the orbits of planets to the atoms that form your heart and bones. The same angular momentum that shapes galaxies also shapes you. Our planet's spin determines the rhythm of your days, the tides of your sleep and wakefulness, the gentle sway of seasons that mark the passage of time. Your entire biology, your heartbeat, your breath, your circadian rhythm is synchronized to the turning of the Earth. Every sunrise and sunset is a reminder that you are living inside a spinning system, one so steady and ancient that it feels like stillness. But the connection runs even deeper. down to the smallest scales of existence. The particles that make you, the electrons, protons, and neutrons in every cell, each possess intrinsic spin. This quantum rotation determines how they interact, how atoms bond, how chemistry works. Without spin, atoms would collapse into sameness. There would be no structure, no complexity, no life. Your body's every molecule depends on this hidden rotation, the tiny whirling motions that give the universe texture and possibility. Even life itself carries the imprint of motion. In the microscopic world, biological systems are full of spirals, the double helix of DNA, the coils of proteins, the twisting motion of molecules and cells. These forms aren't random. They are the biological descendants of cosmic spin, the way matter naturally organizes itself under energy and motion. From the spiral galaxies in the sky to the spiral within your very cells, the geometry of life mirrors the geometry of the cosmos. And though we walk upon the surface of Earth feeling stationary, we are never truly still. Right now, you are rotating with the planet at over 1,600 kilometers per hour at the equator. You are orbiting the Sun at 107,000 kilometers per hour. And that Sun itself is circling the galactic center at 828,000 kilometers per hour. All of that motion passes through you, every atom, every thought, every heartbeat, without your ever feeling it. You are, in every sense, a moving part of a moving universe. When you spin in a dance, or turn your head to follow the stars, you are reenacting something ancient, the primal gesture of motion that shaped everything. The same physics that governs galaxies governs you. The centrifugal balance in your body as you twirl mimics the balance that keeps planets in orbit. The joy you feel in spinning may be more than instinct. It may be the universe remembering itself through you. You are not separate from the cosmic dance. You are made of the same stardust, carved by the same laws, kept in motion by the same momentum that has turned since the beginning of time. Every cell in your body is a participant in that endless rotation, a quiet testament to the truth that everything spins, from the vastness of galaxies to the smallest flicker of life. So when you breathe, when you move, when you simply exist, you are part of the great turning. And in that belonging, you too are spinning still. Life itself depends on spin. Earth's rotation drives the cycles of day and night, circadian rhythms, the growth of forests, the migrations of animals, and the heartbeat of time. Every living thing on this planet dances to Earth's turning. The rotation of our world is not just a physical motion, it is the metronome of life, setting the tempo for all living rhythms. From the gentle opening of flowers at dawn to the silent drift of plankton following the moon's glow, every heartbeat, every breath, every sleep is part of a vast, planetary pulse, a rhythm born from the spin of a world in motion. As Earth rotates, it divides light from darkness, creating the alternation of day and night. This daily cycle has shaped life for billions of years, sculpting our biology to move in harmony with the turning sky. Deep within our brains, a cluster of neurons called the suprachiasmatic nucleus keeps time by sensing light, synchronizing our internal clocks to the planet's spin. These circadian rhythms govern when we wake, when we sleep, when we heal, and when we dream. Without Earth's rotation, the natural cadence of life would collapse into stillness, and time itself would lose its meaning. Plants, too, listen to the Earth's turning. As sunlight sweeps across the globe, forests breathe in carbon dioxide by day and release oxygen through the night. Flowers open and close with astonishing precision, following invisible signals written in the geometry of the sun's motion. Even the growth rings in trees record the rhythm of Earth's spin, tracing time as the planet turns, each ring a testament to another orbit around the sun. Animals navigate by this cosmic clock as well. Birds migrate using the positions of stars that shift nightly across the spinning sky. Sea turtles hatch and crawl toward the moonlit ocean, guided by patterns of light determined by Earth's rotation. Even microscopic life forms, tiny bacteria and algae, rotate their internal chemistry in sync with the rise and fall of sunlight. The entire biosphere is tuned to a single frequency, the 24-hour heartbeat of a spinning world. This rhythm extends beyond biology. It shapes the planet itself. The rotation of Earth drives winds and ocean currents, creating weather patterns, shaping climates, and distributing heat across the globe. Without spin, the planet would be locked in extremes, one side scorched in perpetual day, the other frozen in eternal night. Instead, rotation creates balance. A continuous cycle of warming and cooling, light and dark, movement and rest. Even our sense of time, of progress, of continuity, is born from this motion. Every culture, every calendar, every ritual of sunrise and sunset is a reflection of the turning Earth. The very concept of a day is a measurement of rotation, a unit of existence grounded in the steady movement beneath our feet. And yet, we rarely feel it. To us, Earth's spin is silent, invisible, gentle. We live inside it so completely that it becomes the background hum of our lives, the pulse we no longer notice but cannot live without. Still, its effects are everywhere. In the tilt of a sunflower, in the migration of whales, in the beating of your heart as night falls and the body prepares for rest. The rhythm of life is not random, it's inherited. From the birth of our planet to the flutter of your pulse, spin has been the universe's way of keeping time. Each revolution of Earth carries not only the planet, but everything that lives upon it, through a continuous cycle of renewal. And so, every dawn is not just another morning, it's a reminder that you are part of the same eternal rhythm that began with the first turn of the cosmos. The Earth spins, and we live within its motion, synchronized to the heartbeat of a planet that never stops turning. Every storm, every breeze, every ocean current owes its motion to Earth's spin. The Coriolis effect turns wind into hurricanes. Planetary echoes of cosmic rotation. The air above us moves not at random, but in graceful spirals written by the turning of our world. As Earth rotates, its surface moves faster at the equator than near the poles. This difference in speed bends the paths of winds and currents, giving rise to a global choreography of motion. What begins as simple convection, warm air rising, cool air sinking, becomes, through spin, the intricate dance of weather. The Coriolis effect, named after the 19th century French scientist who first described it, is the invisible hand behind this movement. As air and water travel across the planet's surface, Earth's rotation causes them to curve, rightward in the northern hemisphere, leftward in the southern. This subtle deflection gives shape to the great swirling systems we see from space. Cyclones, jet streams, and ocean gyres, all spiraling in perfect harmony with the planet's rotation. Without this effect, wind would blow in straight lines, and weather would lose its dynamic, ever-changing form. Every hurricane is, in essence, a living monument to Earth's spin. It begins as a cluster of thunderstorms over warm ocean waters, feeding on heat and moisture. But as the system grows, the Coriolis effect sets it spinning. The rising air twists into a vast, rotating vortex, drawing energy from the sea and momentum from the turning Earth. At its peak, a hurricane becomes a self-sustaining engine of motion, hundreds of kilometers wide, powered by rotation, echoing on a small scale the same principles that govern galaxies. Even the trade winds that carried ships across oceans and shaped civilizations exist because of the planet's spin. Warm air rises at the equator, flows toward the poles, and is deflected into steady east-to-west currents. These winds form the arteries of our atmosphere, circulating heat, moisture, and life around the world. The oceans, too, follow the same rhythm. Massive gyres swirl in each basin, transporting warm and cold water across thousands of miles, stabilizing climates, and feeding the currents that sustain ecosystems. Without Earth's rotation, weather would become unrecognizable. The planet would divide into two extremes, one side locked in endless daylight, blistered and dry, the other in perpetual night, frozen and silent. the atmosphere would stagnate, stripped of its spiraling beauty. It is rotation that gives rise to balance. To the storms that cleanse the air, to the winds that bring rain, to the breezes that carry the scent of life across continents. The same laws that twist hurricanes into being also govern the shapes of galaxies and the orbits of moons. From the swirl of clouds over an ocean to the spin of the Milky Way, rotation binds the small and the vast together. Each storm that sweeps across Earth is a miniature reflection of cosmic motion, a fleeting reminder that even our planet's weather is a consequence of the universe's eternal turning. So the next time you feel the wind against your face, remember, that breeze began in the spin of the world beneath your feet. You are standing on a moving sphere, surrounded by the breath of its rotation, a wind born from the same physics that set the stars themselves in motion. The storm, the gust, the whisper of air through leaves, all of it is the Earth remembering how to turn. Einstein's relativity tells us that space and time are linked, and spin can bend both. Rotating masses drag space-time around them, subtly twisting the flow of seconds and light. We often imagine time as something steady, a constant river flowing forward. But in Einstein's universe, time is flexible. It stretches, bends, and warps in the presence of mass and motion. When an object spins, it doesn't just move through space. It takes space and time along for the ride, pulling the fabric of reality into its swirl. This phenomenon, called frame dragging, means that rotation can literally twist time itself. Near a massive rotating body like Earth, the effect is faint but real. Satellites orbiting our planet experience tiny deviations from their expected paths because Earth's spin slightly drags space-time around with it. These subtle distortions were first detected by the Gravity Probe B experiment in 2011, confirming Einstein's century-old prediction. Though minuscule, they reveal a profound truth. Motion doesn't just exist in space-time, it shapes it. The very geometry of the universe remembers every turn. As the scale of spin grows, so does its power over time. Around neutron stars and black holes, objects spinning hundreds of times per second, the warping of space-time becomes dramatic. Time itself slows down near their surfaces, stretched by gravity and twisted by rotation. Light emitted from these regions is bent, its path curved by the vortex of spinning space-time. In extreme cases, such as near a Kerr black hole, time and space become so entangled that one cannot move without the other. To orbit a spinning black hole is to surf the tides of time itself. Even light, which always travels at the same speed through vacuum, can be influenced by spin. As it passes near a rotating mass, its direction and polarization shift, a subtle dance between motion and geometry. Photons curve and twist, tracing the invisible contours of space-time's rotation. What we perceive as gravity is, in truth, the bending of the rules of time and space by motion. If we could observe this directly, if our senses were sharp enough, we would see time as a vast ocean, stirred and spun by every rotating star, planet, and atom. Each mass would create tiny whirlpools of duration, small eddies in the current of existence. Time would not flow evenly, but ripple and twist like a breeze across a field of grass. The seconds you live here on Earth are not the same as those passing near Jupiter, or a black hole, or in the emptiness between galaxies. Each location, each spin, defines its own tempo. This bending of time connects us all. The rotation of the Earth doesn't just create days and nights, it defines how fast we experience them. A clock at the equator, moving faster with the planet's spin, ticks ever so slightly slower than one at the poles. It's imperceptible, but measurable, a small reminder that time is not a universal beat but a local rhythm, influenced by motion itself. In a cosmic sense, spin is the hand that stirs time's flow. Every rotation, from the smallest particle to the grandest galaxy, contributes to the geometry of the universe's clockwork. The motion of matter and the passage of time are two sides of the same coin, woven together in the equations of relativity. And so, when we speak of time flowing, perhaps it's more accurate to imagine it turning. Not a line, but a spiral, forever twisting, forever shaped by motion. The spin of the cosmos is not just the story of where things move, but how time itself unfolds. Every turn of a planet, every rotation of a star, every spiral galaxy drifting through the void, all are part of the same eternal mechanism, the spin of time itself. Time moves forward, yet spin is circular. One gives direction, the other gives rhythm. Together, they form the heartbeat of the universe, progress wrapped in repetition. The universe unfolds as both a journey and a dance. Time's arrow drives everything forward, from birth to decay, from creation to collapse, while spin loops that journey into patterns, cycles, and orbits. Every atom, planet, and galaxy moves through time's linear flow, but does so in spirals, not straight lines. The arrow and the circle are the twin geometries of existence. One defines change, the other defines continuity. Time, as we experience it, seems relentless. Stars age, mountains erode, civilizations rise and fall. Entropy, the tendency toward disorder, gives time its direction, its forward pull. Yet within that inexorable progression, rotation offers balance, a counterpoint to the march of decay. Spin recycles energy, stabilizes motion, and keeps the cosmos from dissolving into chaos. It is nature's way of remembering how to move, even as time forgets. Every cycle we observe, the rising and setting of the sun, the phases of the moon, the turning of the seasons, is born from rotation. The Earth spins on its axis and orbits the sun, while the moon circles Earth, creating a nested rhythm of motion upon motion. These rotations repeat endlessly, but never perfectly. Each cycle brings subtle change, a forward movement woven into the repetition. That is the paradox of existence. The circle carries us onward, not back. In human life, this pattern echoes deeply. Our hearts beat in cycles, yet each beat carries us forward. We sleep and wake, live through years marked by recurring seasons, and yet time moves in one direction. The arrow of time makes us mortal. The circle of spin gives our days their rhythm. Without one, there would be no story. Without the other, there would be no music. On the cosmic scale, the same interplay holds true. Stars are born, live, and die in linear sequence, but their ashes seed new stars, closing the loop. Galaxies spin through space while expanding away from each other, stretching the fabric of time even as they trace eternal spirals. The universe itself may be expanding, but its structures turn in circles, like clock gears inside a mechanism that never stops ticking. Even in the equations of physics, time and rotation are inseparable. Angular momentum is conserved, the circle never dies, while entropy ensures that time never reverses. The result is a universe both stable and evolving, rhythmic yet irreversible. Every turn of a planet, every spin of an electron, every orbit of a galaxy is both an echo of the past and a step toward the future. Perhaps that is why we find beauty in cycles, the sunrise, the tides, the heartbeat, the turning of the stars. Deep down, we recognize that circular motion is not confinement, it is renewal. The arrow moves us forward, but the circle teaches us how to endure. In the quiet tension between these two lies the universe's rhythm, time flowing ever onward, motion looping endlessly back upon itself. The cosmos advances, but it does not forget. It moves in spirals, like a song repeating its refrain as it climbs to higher keys. The arrow gives us purpose, the circle gives us peace. Together, they weave the great continuity, the heartbeat of the universe, pulsing eternally between what was, what is, and what will be. When galaxies collide, their combined spins create new shapes, elliptical, spiral, ringed. Out of destruction emerges order, a new balance of cosmic motion. In the vastness of space, even violence has grace. Galaxies, each containing hundreds of billions of stars, do not drift alone forever. Gravity draws them together, slowly, irresistibly, until their edges touch, their stars mingle, and their delicate spirals begin to distort. What seems, at first glance, like destruction is in truth a kind of rebirth. A merger of motion, a reshaping of spin. When two galaxies meet, their stars almost never collide directly. The distances between them are too immense. Instead, gravity performs the interaction, pulling and twisting each structure into new patterns. Their spiral arms stretch like ribbons, intertwining in luminous bridges of starlight. Clouds of gas and dust, compressed by tidal forces, ignite in furious waves of star formation. Whole generations of new suns are born in the chaos, shining bright where the old structures dissolve. The galaxy's spins, too, begin to merge. Some align, reinforcing one another into greater rotational power. Others clash, cancelling or redirecting their motion. Over millions of years, this dance of momentum finds equilibrium again, settling into a new shape, a single, larger galaxy. It spins slower but more stable, the memory of its ancestors written in its stars. Elliptical galaxies often emerge from such unions, smooth and round, their ordered rotation replaced by a collective, random motion of billions of stars. Other mergers yield rings or warped spirals, patterns of motion frozen in time, as if the universe paused to admire its own choreography. The famous antennae galaxies, captured in stunning detail by the Hubble Space Telescope, show this process mid-step. Two galaxies colliding, their arms flung wide, their spins entangled in the act of becoming something new. Our own Milky Way is not immune to this cosmic fate. In about 4 billion years, it will collide with our neighbouring galaxy, Andromeda. The two will pass through each other like ghosts, their shapes torn apart and reborn. For a time, the night sky from any surviving planet will be ablaze with light, stars strewn across the heavens in luminous arcs. Eventually, the two galaxies will merge into one, an enormous elliptical system, its rotation reshaped, its future rewritten by the physics of motion and gravity. What is remarkable is how consistent this process is across the universe. Every collision, no matter how chaotic, obeys the same rules of angular momentum. Nothing is wasted. The spin of each galaxy contributes to the whole, ensuring that even in destruction, energy and order persist. The universe does not stop moving. It reorganizes itself. And these mergers are not rare exceptions. They are the mechanism of evolution at the cosmic scale. Galaxies grow through collisions. The structures we see today were sculpted by billions of years of encounters and mergers. The smooth ellipticals, the grand spirals, the ringed galaxies with glowing halos, all are the fossils of motion, the outcomes of collisions that turned chaos into form. In this way, the universe mirrors life itself, creation and destruction intertwined, movement shaping destiny. Just as ecosystems evolve through cycles of renewal, galaxies evolve through collisions, preserving their momentum even as their forms transform. Each merger carries forward the memory of the old spins, blending them into a new rhythm, a continuation of the universe's endless turning. So when you look at a photograph of colliding galaxies, don't see violence. See the universe learning to move anew. Every swirl of dust, every twisted arm of starlight, every glowing bridge between galaxies is a signature of motion, finding harmony again. Out of collision comes balance, out of chaos, rotation. Out of endings, the spin of the future. Asteroids, comets, and moons all retain the angular momentum of the solar system's birth. Even now, they silently record the universe's first great twirl. Long before planets formed, before the sun began to shine, our solar system was nothing more than a swirling disk of gas and dust, spinning, collapsing, and condensing under the pull of gravity. Every particle within that primordial nebula shared in the same grand rotation, orbiting a common center that would one day ignite into our star. As the ages passed, most of that material joined the planets, but countless fragments remained: asteroids, comets, and moons, still moving, still spinning, carrying within them the original momentum of creation. Each asteroid is a fossil of motion, a remnant left untouched by time. Some tumble irregularly through space, spinning chaotically after eons of silent collisions. Others rotate with clockwork precision, turning once every few hours as they trace their paths around the sun. Their spins are shaped by ancient impacts, by gravitational nudges from nearby planets, by the faint push of sunlight itself. Yet beneath all these influences lies the same inherited energy, the angular momentum of a collapsing solar cloud 4.5 billion years ago. Comets, too, tell this story. As they approach the sun, their frozen surfaces vaporize, releasing jets of gas that act like thrusters, altering their spin. Some begin to wobble, others to tumble end over end. Their long, luminous tails trace the paths of their orbits, shimmering reminders that even the coldest, quietest bodies in the solar system are alive with motion. Each turn of a comet, each flicker of its icy nucleus, is the universe remembering its first rotations. Moons preserve these memories on a grander scale. Many spin in synchrony with their planets, locked in perfect resonance, the same face always turned toward their parent world. Others, like Saturn's moon Hyperion, spin chaotically, its irregular shape and orbit preventing it from ever settling into a steady rhythm. Still others, like Jupiter's Ganymede, carry traces of their formation deep within, their internal rotations driving magnetic fields and geological activity. Whether steady or wild, each moon is a monument to motion, a satellite born of ancient spin. Even the tiny fragments between planets, the grains of dust that drift through interplanetary space, turn as they move. Light itself can make them spin, a phenomenon known as the Yorp effect, where sunlight's uneven pressure changes an object's rotation over millions of years. It is a delicate reminder that motion is always being rewritten, yet never erased. Together, these small worlds, asteroids, comets, moons, are the scattered archives of the solar system's memory. They carry the fingerprints of collisions, the scars of creation, the geometry of movement frozen in form. Some are remnants of shattered planets, others are wanderers from distant regions beyond Neptune, yet all share the same ancient rhythm. The slow, eternal spin that began with the first great collapse of matter around the newborn sun. When we send spacecraft to visit them, when probes land on comets or orbit asteroids, we are not just exploring dead rocks, we are studying time capsules of motion, holding the preserved dance steps of the universe's earliest moments. Each rotation tells a story older than Earth itself, a record of the universe's first twirl made solid, enduring, and real. In their silence, they remind us of something profound, that creation was never a single event, but a continuous turning. The universe spins in everything it makes, and everything it makes remembers. From the spin of an asteroid to the orbit of a planet, from the swirl of galaxies to the twirl of atoms, motion is not an afterthought. It is the handwriting of the cosmos. The relics still turn, untouched and unbroken, drifting through the dark between planets. They are the fragments of the first motion, still whispering the same message that began it all. Nothing ever truly stops. MRI machines on Earth work because atomic spins align in magnetic fields. By listening to those tiny rotations, doctors can see inside the human body, a cosmic principle turned personal. Deep within your body, trillions of atoms are spinning. Each nucleus, especially those of hydrogen, abundant in water and organic tissue, acts like a tiny magnet, its spin creating a subtle magnetic moment. These microscopic rotations, born in the first seconds after the Big Bang, still hum quietly within you, forming a bridge between the mechanics of the cosmos and the miracle of life. When you step into an MRI machine, the same laws that govern galaxies at the edge of the universe are called upon to reveal the invisible landscapes of your own body. An MRI, or magnetic resonance imaging system, uses an immense magnetic field to align the spins of hydrogen nuclei inside your tissues. In their natural state, these spins point in random directions, cancelling one another out. But under the influence of a powerful magnetic field, tens of thousands of times stronger than Earth's, the spins gently align, all tilting toward the same invisible axis. In that moment, the atomic chaos within you becomes ordered, and your body becomes a map of magnetic motion. Then, a pulse of radio waves briefly disturbs that alignment, nudging the spins out of place. When the pulse stops, the atoms relax back into position, releasing faint radio signals of their own. These signals are detected, measured, and translated into images, each one a pattern of energy born from the behavior of spinning particles. The result is astonishing. A clear, detailed picture of your internal world, created not by light or touch, but by listening to the whispers of atomic rotation. What makes this so profound is not just the technology, it's the principle. The universe's oldest and most fundamental property, spin, is the reason we can look inside ourselves without a single incision. The same quantum motion that keeps electrons in orbit around nuclei also governs the subtle interactions of matter and magnetism that make MRI possible. The circular movement of atoms, the smallest, most ancient form of rotation, has been transformed into a tool for healing and understanding. In a way, every MRI scan is a reminder that the cosmos is not out there, it's in us. The atoms that make up your body were forged in spinning stars, born in explosions that hurled matter into space, where it gathered, cooled, and found its way into living cells. Their spins have never stopped. The same angular momentum that once helped shape galaxies is now guiding physicians' hands, turning cosmic physics into medicine. Each flicker on an MRI screen is a kind of echo from the Big Bang, a pattern of motion that has endured for nearly 14 billion years. You are not just a passenger in the universe's rotation, you are made of it. Your atoms turn, your heart beats, your planet spins, and all of it flows from the same principle. That motion is the foundation of existence. So when the hum of an MRI fills the room, you are hearing more than a machine. You're hearing a symphony of spins, the same rhythm that drives the stars. The universe has been turning since time began. And now, through the quiet rotations inside you, it sees itself reflected. What began as a cosmic dance has become something deeply human, the spin of the universe, healing its own creation. Everything that spins resists change. That resistance, gyroscopic stability, gives planets their steady axes and spacecraft their orientation. Spin creates order from motion. If you've ever held a spinning top in your hand, you've felt the quiet power of this principle. As the top turns, it resists your attempts to tilt or twist it. Instead of falling, it steadies itself, its motion creating its own kind of balance. That's not magic, it's angular momentum at work. In the spinning world, movement is stability. From the toy on your desk to the planets in orbit, gyroscopic stability is the universe's secret way of keeping chaos at bay. When an object spins, it stores angular momentum, a property that resists changes in direction. Try to tilt a spinning wheel, and it pushes back, not by force, but through the graceful geometry of rotation. The result is precession, a slow, steady wobble that redirects rather than destroys motion. This elegant resistance is what keeps Earth's axis tilted at roughly the same angle for millions of years, maintaining the rhythm of the seasons and the stability of climate. Without it, our planet's poles might drift wildly, and life as we know it could never have adapted to such chaos. This same principle guides the spacecraft that explore our solar system. Gyroscopes on board, small, rapidly spinning wheels, allow them to maintain their orientation even in the frictionless void of space. By measuring and adjusting the direction of these spins, engineers can point telescopes toward distant stars or steer probes through the gravity wells of other worlds. The James Webb Space Telescope, for instance, relies on gyroscopic sensors to stay perfectly balanced, keeping its golden mirrors fixed on targets billions of light years away. Spin, once again, becomes order. The gyroscope's gift is predictability in a universe ruled by motion. It transforms potential chaos into graceful steadiness. In the same way, every rotating planet and moon behaves like a vast cosmic gyroscope. Jupiter's rapid rotation stabilizes its storms and magnetic field. Saturn's spin keeps its rings in delicate harmony. Even our Sun, rotating once every few weeks, maintains the orientation of its magnetic poles through this same stabilizing effect. Across scales great and small, spin is what allows the universe to hold its shape. But gyroscopic stability doesn't mean stillness. It means resilience through motion. Even as Earth's axis slowly precesses, tracing a great circle in the sky every 26,000 years, it does so with rhythm and grace. This slow wobble, like the turning of a cosmic top, connects ancient skywatchers to modern astronomers, each seeing the stars shift slightly over generations. The heavens themselves move, yet they remain reliable enough to steer ships, mark seasons, and measure time. In our daily lives, the same physics governs everything, from bicycles to satellites. A cyclist stays upright not because of balance alone, but because their wheels spin. The faster the rotation, the more stable the motion. A spinning coin resists falling flat. A fidget spinner holds its plane. Even atoms and particles, with their intrinsic spin, behave as microgyroscopes, their stability defining the structure of matter itself. It's as if the universe discovered a profound truth in its own first moments. That motion is not the opposite of order, but its foundation. Everything that spins, from the smallest electron to the grandest galaxy, carries within it a stabilizing power, a resistance to chaos. Spin is the quiet architect of persistence, the unseen hand that keeps the cosmos upright. So the next time you see a spinning top, remember, it's not just a toy, it's a miniature echo of the universe. Its balance, its rhythm, its graceful resistance to falling all arise from the same laws that hold worlds steady and guide spacecraft among the stars. Spin doesn't just create motion, it creates reliability. It is the gyroscope of reality, the mechanism by which the universe keeps its balance while it turns forever through the dark. Zoom out or in, and the pattern repeats. Electrons, storms, planets, galaxies, all turning, all following the same geometry of motion. The universe loves patterns. Look closely, and you'll find that its design repeats across every imaginable scale. From the smallest particles whirling in atoms to the spiraling arms of galaxies, rotation appears again and again, as if the act of spinning were a universal language, written into the fabric of reality itself. Spin is not random, it's recursive. It echoes across magnitudes of space and time, revealing that creation itself may be fractal, built from self-similar motions, repeating endlessly at different scales. At the atomic level, electrons exhibit an intrinsic property called spin, a quantum twist that defines how they occupy space and interact with other particles. Though it's not spinning in the classical sense, it carries the same essence: angular momentum, direction, polarity, rhythm. It's this hidden motion that allows atoms to bind, matter to organize, and chemistry to unfold. The very building blocks of your body are shaped by rotational symmetry. Zoom outward to the scale of weather, and you see the same principle play out in the atmosphere. Storms, hurricanes, and cyclones twist because of rotation, because Earth itself turns beneath them. Each storm is a living fractal, its swirling arms mimicking the spiral galaxies that hang in space, its eye calm and centered like a galactic core. The Coriolis effect, born from planetary spin, transforms chaotic motion into elegant, self-organizing structures. What we call weather is the fractal breath of a spinning planet. Zoom farther still, and the same geometry appears in the heavens. Planets orbit stars in curved, spinning paths. Galaxies form vast spirals, their arms wrapping around centers of mass in ratios that mirror seashells, whirlpools, and even the curves of living plants. This is not coincidence, it is mathematics made visible. The Fibonacci sequence, the golden ratio, and logarithmic spirals appear everywhere, linking storms to galaxies, DNA to nebulae, leaves to planetary disks. Nature repeats its patterns like a refrain in a cosmic song. Even at the grandest scales of all, the universe itself might be spinning. Astronomers have found hints that clusters of galaxies and cosmic filaments show preferred directions of rotation, a subtle asymmetry suggesting that the cosmos inherited its own angular momentum from the Big Bang. If so, every twirl, every orbit, every hurricane and electron is part of one vast cascade of motion, descending from that first rotation. Fractals are not mere shapes, they are processes, patterns of growth that repeat infinitely, and so too is spin. Whether it's the swirl of cream in a cup of coffee or the arms of a spiral galaxy, the motion follows the same physics: conservation, symmetry, flow. It's as if the universe cannot help but spin itself into beauty. Perhaps that's why we find spirals so captivating. From snail shells to storms to star systems, our eyes and minds are drawn to their form. We sense, at some deep level, that they're not just beautiful, they're fundamental. They're the signature of motion itself, a reminder that we are part of a vast continuum of turning energy. Spin, then, is the universe's fractal fingerprint, the repeating imprint of its birth and being. It reveals that everything is connected by motion, each level of reality mirroring the next. The electron's dance mirrors the planet's orbit. The hurricane's eye mirrors the galaxy's core. It's all the same pattern, the same principle, expressed in infinite variation. The cosmos doesn't just move, it repeats itself through motion. Every twirl, every rotation, every spiral is the universe remembering its own design. Spin is the fractal heartbeat of creation, an unbroken rhythm that binds the smallest atom to the farthest star, echoing forever through the geometry of existence. Every spin hides a paradox. At its center lies perfect stillness. The axis of rotation, motionless yet vital, reminds us that peace and movement can coexist. In every turning thing, there is a quiet heart. A spinning top whirls so quickly it blurs into stillness, yet at its very core is an unmoving point, the axis upon which all motion depends. The same is true of the Earth, the Sun, and the galaxies themselves. Each revolves endlessly, yet at the center of each rotation lies calm, a point of perfect balance where movement becomes serenity. In the heart of motion lives stillness, and in stillness, the potential for motion is born. If you could stand at the very center of the Earth's spin, directly on its axis, the planet would rotate around you in silence. You would feel nothing. The air would move, the stars would shift, but your position would remain unchanged. You would be the calm eye in a planetary storm, a living reminder that even in constant motion, equilibrium is possible. The same principle applies to everything that turns. A hurricane's eye is eerily tranquil, a serene hollow surrounded by chaos. The furious winds spiral around a motionless core, sustained by the very stillness they encircle. Galaxies, too, follow this geometry. Their bright arms whirl through space, yet their centers, massive black holes, are paradoxically defined by motion so extreme that it collapses into stillness. Even at the heart of those cosmic maelstroms, there is order, symmetry, and silence. Perhaps this paradox is not confined to the physical world. Within us, the same pattern holds. Our lives spin with movement, thoughts, emotions, responsibilities, endless change. And yet, deep inside, there is a center that does not move, the quiet axis of awareness. It is the still point around which our experiences revolve. We feel its calm when we pause, breathe, or look at the night sky and remember how vast everything truly is. The spinning of the universe mirrors the turning of the mind, and both find balance when they remember the center. In the mathematics of rotation, this stillness is fundamental. Every spinning object depends on its axis, a line of zero motion that defines the direction and stability of the turn. Without that unmoving reference, the motion itself would dissolve into chaos. Spin cannot exist without stillness. The two are inseparable, opposites entwined in harmony. Even the universe, for all its restless expansion and ceaseless motion, may possess its own still point, an underlying equilibrium that keeps the whole from tearing apart. Cosmologists sometimes call it the cosmic frame, the quiet reference against which all other movement is measured. If it exists, it would not be a place, but a condition, a state of perfect symmetry beneath the turbulence of existence. And perhaps that is the truest lesson of spin, that motion and peace are not opposites, but reflections of one another. The faster the rotation, the deeper the stillness at its core. Every orbit, every turn, every heartbeat carries this dual truth, that life moves because it has a center, and that center endures because life moves around it. In the end, the universe teaches balance through its very structure. The stars whirl, the planets turn, the galaxies drift in endless circles, and yet, beneath it all, there is a silence that holds them steady. To find peace is not to escape motion, but to find your axis within it, the point of stillness where the spinning never disturbs you. Every rotation in the cosmos hides this same secret. At the heart of movement lies rest. The still point within motion is the universe's quiet truth, a reminder that even in eternal turning, there is always a place of perfect calm. Perhaps the universe spins because it must, because without motion, there can be no time, no matter, no life. Spin is the cosmos teaching itself how to move beautifully. In the beginning, there was no rhythm, only expansion, chaos, and light. But from that formless energy came the first patterns, the first gentle whirls of matter finding balance. Motion found meaning, energy became structure, gravity found its partner in spin, and together they choreographed everything that would ever exist. The universe didn't simply begin to spin, it learned to. Every particle, every star, every galaxy became part of a grand, unfolding performance. What began as a primal flutter of imbalance became elegance, repetition, and order. The cosmos learned that to endure, it must dance. That motion, when guided by symmetry, creates harmony instead of chaos. It's a dance that transcends scale. On the smallest stage, quantum particles pirouette in ways that define chemistry and matter. On the largest, galaxies swirl through space like cosmic ballerinas, tracing arcs of light and shadow. The same choreography unfolds everywhere, from the spin of electrons in your cells to the rotations of entire galaxy clusters. The steps change, but the rhythm remains. The beauty of this cosmic dance lies in its duality, precision, and improvisation. The laws of physics set the rules, but within them, randomness and creativity bloom. A collapsing star becomes a supernova. Two galaxies collide and form a spiral. A cloud of dust becomes a planet. Each turn of motion is both predictable and new, a universe discovering, again and again, how to move. If spin is the universe's heartbeat, then gravity is its music. Gravity draws everything inward, while spin sends everything outward. Between them lies the perfect tension that keeps the dance alive. Without gravity, motion would scatter into emptiness. Without spin, gravity would pull everything into silence. Together, they keep the universe twirling, balanced, alive, and in motion. We are part of that same choreography. The atoms in your hands once danced inside stars. The blood in your veins flows in spirals, following the same geometry that shapes hurricanes and galaxies. Even your thoughts, your dreams, your heartbeat, each follows the rhythm of a turning world beneath a turning sky. You are not watching the universe dance, you are the dance. And perhaps that's the deepest secret of spin, that it isn't just physics, it's expression, motion made meaningful. The universe moves not only to exist, but to become. Every rotation is a gesture of creation. Every orbit a step in an endless waltz that began with the first burst of light. When we look up at the night sky, we are seeing the universe mid-motion, a dancer caught in a pose billions of years long. The galaxies swirl, the stars pulse, the planets roll through their orbits, all moving to a rhythm older than time itself. And though we can't hear the music, we feel it, deep in our bones, in the spinning of our cells, in the turning of our world. Perhaps the universe spins because that is what beauty does when it finally understands itself. Motion is not an accident. It is awareness finding grace. The cosmos doesn't just exist, it performs. Every atom, every star, every living being is part of its choreography. The universe didn't merely come alive, it learned to dance. And through every rotation, every spiral, every beat of time, it still dances, teaching us, too, how to move beautifully through the infinite. Trillions of years from now, when the stars have faded and galaxies have cooled, spin will remain, the last echo of energy in a universe grown silent. Even at the end, the dance continues. The story of motion is also the story of time, and like all stories, it drifts towards stillness. One by one, the lights will go out. The youngest stars will burn through their fuel, the galaxies will dim, and the universe will grow cold and wide. Motion, the universe's oldest instinct, will refuse to fade entirely. Even as matter thins and light weakens, spin will endure, like a single note trembling at the edge of silence. Long after the last suns have gone dark, black holes will still turn. Their immense spins will continue to twist space-time, powering faint jets that pierce the void. Over unimaginable eons, even they will evaporate, their mass leaking away through Hawking radiation. But before they vanish, their rotation will have flung the final sparks of motion into eternity, whispers of angular momentum that carry on after everything else has stilled. Planets, moons, and asteroids, those relics of creation, will continue their orbits for billions upon billions of years, slowing imperceptibly as friction, collisions, and gravity's faint drag wear them down. Some will be swallowed by fading stars, others will drift into the dark, frozen, turning slowly in a silence deeper than thought. Even then, they will remember their first momentum. Even then, they will spin. By then, time itself will have stretched beyond comprehension. Galaxies will have drifted so far apart that their light can no longer bridge the distance. The cosmic web will dissolve into isolated islands of matter, each one adrift in a sea of expanding space. Temperature will fall toward absolute zero. Entropy will reign, yet, at the smallest scales, motion will persist, electrons orbiting faintly, protons spinning within atoms, quantum particles vibrating in the emptiness. The universe, though faint and slow, will still be moving. Perhaps that's how the cosmos says goodbye. Not with a crash or a cry, but with a whisper, a long, graceful deceleration that never quite reaches zero. Motion, the essence of everything that ever was, becomes softer, subtler, until it is indistinguishable from stillness. In that final balance, time loses its direction, energy, its urgency. What remains is rhythm without speed, existence without change. The memory of motion, lingering like the last note of a cosmic symphony. Even in this distant future, beyond stars, beyond light, the universe will not truly end. Its rotations will continue, slower and slower, tracing invisible spirals through eternity. The great dance that began with the Big Bang will never stop completely. It will only fade into quiet grace. And if consciousness still exists somewhere, if something remains to watch or remember, it will see a universe at peace. A universe that began in a furious spin and now turns so gently it appears still. The galaxies will no longer shine, but their motion will echo forever, hidden in the geometry of space-time itself. So even when everything slows, nothing is ever lost. The spin remains, the universe's final heartbeat, pulsing faintly in the dark. The last dancer still turns beneath the silence, and through that endless, slowing motion, the cosmos endures, not as flame or light, but as memory. And perhaps that is how it was always meant to end, not with stillness, but with serenity. For even at the edge of forever, when all else is gone, the universe will still remember how to move. Softly now, let your attention float back over the path we've traveled, from the first trembling eddies after the Big Bang to the slow, patient turning of galaxies, stars, and the atoms inside your own hands. We traced how tiny imbalances became great spirals, how angular momentum preserves motion like a memory, how planets inherit their days from spinning birth clouds, and how black holes and dark matter shape the grand ballet. Remember, every rotation carries a story of creation, collision, and gentle balance. Be grateful for this intimate connection, that the same cosmic dance that spirals the Milky Way also warms your days and sets your heartbeat. You are made of spun stardust and ancient motion. You belong to the turning universe. Now breathe slowly. With each exhale, imagine the spinning of worlds slowing to a calm, steady lullaby. Let the image of vast, patient rotation soothe your mind, a quiet, endless circling that holds you safe. As your breathing lengthens, feel the day dissolve into the soft revolution of night. Sleep, carried on the universe's gentle turn,